Hello everybody, how's it going? Let's go ahead and turn this off real quick. Also, there is like construction or something going on outside my window. So if you hear some weird stuff, that is what's going on, and I apologize about that. Hopefully you guys can hear it though. I have no idea. It's very loud for me though. So yeah. But Kirkix, Lime Keys, and Vox Riffs. How's it going, guys? It's good to see you. So, what are we doing today? Today is, as you can see in the little thing down here, GPU vector graphics. Now, why am I doing GPU vector graphics? Well, a while ago, I made this thing and kind of gave up on it. Let's go ahead and see if I haven't run this in a long time. So this is all new code to me too. It's been like, I think over a year. I last touched this in August of last year. So it has been quite a while. So let's see what's going on here. So we go main and then we go run. And inside here, we have a frame buffer. Ah, yes, it's coming back to me. Not really. I still don't know what this is all about. I sort of remember how this works and stuff. But basically, we've just got this whole thing. We've got a play animation. And if we hit space, I think it starts playing the animation. Let's see. Yeah, if we press space, is running as... Oh, no, if we hit F5, then we play the animation. And if we hit F5, it stops. And then... So F5 once, it's running... Oh, no, and then if we hit escape, it stops. No, escape, it closes. Okay. And then if we hit F6, it outputs it to a video file. Okay, so I'm kind of remembering. And this stuff, oof, we're not touching this at all. But anyways, so what does this do? Let's see. It looks like it goes through... I'm trying to see which scene, because I've got several different scenes, I guess. Okay, so it goes to the animation manager update, and the animation manager goes through all the different animation types and updates them. Okay. Still not sure what's going on here. Don't worry, this has a point too. Eventually, it will have a point. Okay, let's see. We have... There's got to be like some sort of update thing in here that goes to the correct... Yeah, sandbox update. I don't know how I missed that. Okay, so sandbox update. And this goes... Here we go. Yeah. And it goes and updates one of these things in animation. And it looks like for this one, it is going... Let's pop that out. It is going into how Bezier works. And then it goes into here. It updates. We just add to our time. And basically... looks like we used to update the Bezier anim, but we don't anymore. I think this has an init, though. Yeah, it does have an init. And this initialization thing does a lot of stuff, too. So if we just hit F5 or run this, we can see what's going on. Sam just came from shop. This is some skeletal animations. No, this is... we're going to be doing GPU vector accelerated graphics. So literally vector graphics on the GPU. Eventually the goal is to replace Manim with this because I don't like Manim. There's oddities and it really annoys me. And there's so many things. We'll talk about that in a minute though. I'm sort of going through the reasoning for what's going on now and what exactly we'll be doing today. But yeah. And DV222, how far are you with Minecraft? As far as we were in the last stream, I have not updated it just because Manim is the math animation library written by 3Blue1Brown. Technically, I use Manim Community Edition, which is by his community. It's what I use to make the animations for my videos. But yeah, I haven't been working on it DV222 because I've been working on my video. So if we hit F5, you'll see this goes ahead and draws a couple lines, and that's basically what this thing is in charge of, I guess. But you'll notice if I hit F6, we get this console output, and I guess we can actually see a preview of what's going on here too. So what this is doing now is it's actually encoding. Oh, I guess it doesn't update over here. I thought it updated over here. Maybe it does, maybe it doesn't. Envir Sechi. I hope I said your name right. Thank you for subscribing. Good to see you. But yeah, what you can see is happening over here is it's literally writing out an output file. Oh yeah, and this is pretty bad. So first of all, it's not showing an output over here. Second of all, it doesn't just stop. So like I have to stop it manually whenever I feel good about how many seconds have been encoded. So say I wanted to stop, I'll just hit F6 again. Or maybe F7. Yeah, okay, I hit F7. Cool. So then it finalizes. And then if we go into our root directory, we can go over here and we see we get an output.mp4. And if I open this up, we get a blank screen. Amazing. Because that's all that was going on. For some reason, it didn't play the actual animation. So that's kind of weird. But basically, what this is this is a library I use to create my original animations for that math library, the math behind font rasterization. However, I never ended up continuing on this because I use Manim now. Manim is basically a library by 3 Blue and Bronze community. We can kind of see what this does real quick. I'll just put this into here. Test manim.py. So basically what you can do is you can say stuff like test scene, and this derives from the scene. Actually, what I'll do is I'll do the 3D scene because I'll show exactly what my issues with this library are, and then we can continue. And then we can do def construct self. And so what we can do then is we can start creating an animation, right? And the way you create an animation in Manim is, and I need to actually import this. Nope, can't do that. Let me go ahead and open up my old file because it'll be easier if I just go through there. Let's see. So this is how I create animations for my videos now, and that's part of the reason it takes so much longer is just because it takes a long time to do this. I think I have, oh no, it's not in C++, it's in Manim. That would make sense. Okay, so if I open this up, yeah, so you can see this is like all the code I'm using and everything. Sam, thank you for subscribing, dude. For 2 more months. Thank you. Okay, so if we go ahead and we pop open a terminal, you can see I've got this thing. And so I say like set the camera's orientation to this. This is 70 degrees about the global z-axis, which is up in Manim, and then 45 degrees around, 45 around the y-axis, and then z, this is around the pitch. So this is like the pitch. This is the yaw. So if I were to go manim-pql, which is low quality, fade in cube looks wrong, and I actually have to pass the scene too. So scene.py, that's the Python file that we're using. So if I go ahead and do all this, it's going to go ahead. It's saying not found because I'm in the wrong folder here. Let's go to the right folder. Manim Minecraft episode 5. Okay, and then if we were to run this command, it's going to go through, render this video out, and then we get this video, right? So it creates some axes, which is what it says to do there, and then it fades in this cube. But look at this cube. So notice how this axis is behind it right now, finishes fading in, and it pops out and corrects itself. This is ugly. And I've reached out on the Manim Discord, and I got an upvote from one of the Manim helpers, but no response. I was like, is there any way to avoid this behavior? And so I'm assuming by the lack of a response, because they've responded to other people, I'm assuming this means there is no way to avoid this behavior. So something this simple shouldn't be a problem, in my opinion. It's just annoying to me. But why do I like Manim? It's because they have this cool text animation thing. And this is the main reason that I have stuck with it. So if we do the gimbal lock visualization, which isn't actually a gimbal lock visualization yet, but if we run this, you'll notice that I get this cool text animation. So if we go ahead, so I get this gimbal lock up here, and let's actually change that to a right animation just so that we can see, because it's pretty cool, and I do like this. So if I were to say self.play right title, then what we can see is the writing animation. You guys know, yeah. Sam, looks like so much effort to just draw simple animation. Yeah, that's my next point too. Okay, so that's like the thing that I like about this, you know? Very cool writing. I also like the interpolations and stuff. They're very smooth. I like them. But once again, you can see we get this gross snapping behavior, and I hate that. So yeah, Also, Voxerifs, good to see you back. Your net died for just a bit. Am I planning to move to my library sometime? Like move... Yeah, that's kind of what this stream is about. We're going to experiment and see if I can get a cool writing animation like this. And as you can see, like, it's not... Yeah, this threw me for a loop for a while. But if we, like, kind of break this down, what's happening here is it's literally just drawing the outline first and then fading the fill. So if we can find a way to draw vector graphics by outlines and fill, then we can find a way to do this, is the thought process. So that's basically what we're going to be experimenting with today. And of course, I'm going to be doing this GPU. They do not have this GPU accelerated. They're apparently working on something, but even then, it's not that great, I've heard, using OpenGL. So, yeah, if we do this ourselves, we can have real-time feedback, which is one. And then, like you said, Sam, seems like a lot of work to make a simple animation. I agree. Most of this stuff is configuration stuff. There's no reason I should be writing code for this. Self.set camera orientation. This is just setting the camera orientation. I should have a visual editor where I can just move the camera and then like set up a timeline. So I have a timeline, move the camera, say, okay, this is where it starts. If I want to move the camera more, I can go to the timeline and say, edit the camera's keyframes. There is no reason it should be this difficult. And then like this, just title.animate.shift up. So I'm just shifting the title up. No reason that this should be, this is all configuration values. This could literally be pulled from a configuration file. It's just, there are a few cases where Manim is helpful. Like you can do something called value updaters where you write code and then you use that code to update something over time. But that's no reason to force everything to be code. You can still have like a visual editor and then just have like, embed Lua or something and then use the Lua code so that you can script certain portions that need a little bit more hands-on material. Or you can even use Lua code for things where like you have loops and stuff where you're doing lots of different things and it'd be easier just to have like a script that creates that stuff. So that is the aim today. We can just discard that. So that's what we're going to be working on, and to do that, we are going to be taking a look at rendering vector graphics on the GPU, Voxerifs. But drawing the outline is kind of interesting. Maybe it's controlled by a time variable to interpolate position on a curve. Exactly, and that shouldn't be that difficult. Once we have all the geometry and we have a way to actually render that, enabling those different flags should be pretty easy. So the hard part is going to be getting it to actually render that stuff. But once we get that, it shouldn't be too bad. So I have this document up. I've literally done like zero preparation for this video, unfortunately. I have been ruminating on this idea for a while though, so I kind of have like ideas running in my head about how this works. Sam, by the way, the editor you are dreaming of right now is Ace Gikmo. She created editor for it in Unity. Is she the girl who did that Bezier thing? Ace Gikmo. Makes you want to write yeah, Freya. Okay, yeah. Yeah, this girl. See, but then I have to use Unity. I'm just kidding. And then I don't get to do it myself, too. Freya is awesome. I agree. I saw that video she did on Bezier curves, which was also an entry into the Manim community. And I was like, oh, crap, I can't compete with that. But I had already chosen my topic by then, and done my video. Too late then. But she's amazing. Yeah, then I'd have to use Unity. Ugh. I mean, that's really not that bad. But I do find it fun to be able to work on it myself. And I've been using a library for a lot of my videos in the past, as evidenced by like my code there and stuff. And this is a reason I kind of want to move away from a library too, is because when there's a problem like this, I reach out on a Discord and I'm waiting, get no response because they don't know how to solve it. And so if I know the code inside and out, then I can just go in and fix it. It's so much easier than waiting for somebody to respond or not to respond because they don't know how it works. So yeah, I'm sure literally everybody saw that video pop up. Yup. I haven't seen any other videos from her pop up though, other than one that was like a 3-hour course on shaders or something. So, okay. So anyways, this is sort of the idea, I guess, and this is what they're showing here. So we basically send vertices, but these vertices aren't like traditional vertices. Instead, what they are is they are control points, right? And so they're saying we can use these control points kind of like, so they'll have a position, obviously, right? Because they've got a position within the font itself. And then they also have like these texture coordinates is what they call them, except they're not texture coordinates. They say we use these UV coordinates to evaluate a procedural texture. And the pixel shader computes the expression u squared minus v. And so this is going to be a kind of math heavy thing because I got to understand what he means by that. So he's saying it's going to be u squared minus v. And the reason this works is because of implicit functions, so parametric functions of how the fonts work themselves. I'm trying to understand how this works though. So u squared minus v. So if this was, he first of all maps these from like a 0 to 1 space, right? And then 0 minus 0. So basically what happens is this is going to get interpolated and then all of this is going to happen at compute time in our fragment shader. I'm still curious though how that generates this. I mean, I guess what we could do is we could just try. So let's upload 3 vertices. We'll give it procedural texture coordinates and then we'll just evaluate this expression. And if it's true, we'll turn it on. If it's not, we'll turn it off. So I thought this was going to be the hard part, but if that's it, this is the easy part. And then the hard part is getting the font's details out of a font file, but I already have some stuff too. So that shouldn't be as bad as I think it is, hopefully. So what we'll do is we'll create like a vector shader .glsl. Maybe vector isn't the best word, but that's what we're going to call it. So let's just check what we're uploading here. And if we can get vertices around the same size as this, I will be happy with that. So if we can get vertices smaller than this, I'll be even happier. So yeah, Goldbear584, thank you for following. Good to see you. So what we'll have is we will have a position, clearly, because we do need that position, and we will need a color too. Okay, and then we can remove this stuff. So already, this is technically what? That's 4 bytes for an int, and then 4 plus 4 is 8. So that's 12 bytes for texture coordinates and a texture ID. But now we can reduce that to location equals 2, invec2 AUV. And I'm not going to call this like texture coords like I usually do, because now this is really, it's like procedural texture coordinates, I guess. I don't know what you would call it, but we'll just call it UV. And I completely blanked on how to write a shader main function. It's void main, not int main, which is what I was about to write. Okay, so we have our void main. We also need our projection in our view, so we will grab those. And it looks like I'm doing in here exactly what I warned you guys not to do, Sam, yesterday. Oh, no, it looks like I am kind of making it safe. Yeah, this isn't the best. I shouldn't be passing a texture ID through a vertex attribute. That's not good. So don't do that. Yeah. I've talked about all the reasons in the Discord, and apparently I'm doing it right here, but don't do that. Okay, anyways, though, why is the spacing weird on that? Oh, it's because I changed my spaces to 2, isn't it? Yeah, let's change that back. Spaces 4. Okay, cool. So we have our projection, our view. We're going to use the same thing here. There's nothing fancy about that. Right, okay. And I guess the interesting thing is we will pass this to our fragment shader. So this will get a invec2 AUV. And then supposedly all we have to do is just say, like, for now, I guess we'll also take in the color. So we'll say invec4 F color, and let's call that F. Then we can do out, out, and then we can just assign those. That's a vec4. Okay, so then supposedly what we can do is we can just say bool inside equals u squared minus v. I think that's what he said. Yeah, u squared minus v. Okay. So that would just be fuv.u times fuv.u, u squared minus v, fuv.v. Can we use uv? Yeah, I think it's like uvwx, right? I think is one of the shader, whatever it's called, Twizzlers. Okay, so, and then we can just say if inside. Say out vec4 frag color, and technically you could do like out layout location, or do we do, yeah, we would do like layout location equals 1 or 0. I think it's 0, yeah, which just like explicitly says output to frame buffer 0 or whatever if you had multiple frame buffer attachments, but I guess that doesn't matter. Okay, so then we could say like frag color equals f color, else we do nothing. Yeah, I think I'm okay with that. We would do nothing otherwise. Just let the pixel kind of fall through. I guess that's kind of the same as discard, but it's not, since, yeah. Okay, so we'll just try this, I guess, and then we'll do exactly what they're doing here. We'll pass 3 vertices, and then we'll pass 0, 0, 1/2, 0, and 1, 1. And we'll see if that works with the shader. So now I gotta figure out how this thing is working. Okay, it looks like we call how Bezier works. So let's go ahead. We're gonna actually add something to our renderer, and let's go into here, renderer. Okay, so I've already got something for fonts in here too, it looks like. I just never actually finished with this. So this is good. We might be able to just use this whenever we get around to that. Seems weird to me to just evaluate float to bool. Oh, did I do that? Oh, yeah. That's true. What did they say? They said if it equals 0 or something. No, they just said it. Okay, wait. So what does u squared minus v mean? Thank you for bringing that up, Sam. That is true. Okay, using the sign of the result to determine pixel inclusion. For convex curves, a positive result means the pixel is outside the curve. Otherwise, it's inside. For concave, the test is rejected. Okay. Thank you, Sam. That good call out. Using the sign of the result to determine pixel inclusion. So what we'll do is we'll say if this is greater than 0, it's inside. Otherwise, it's not. Yeah, that makes a lot of sense now. So, and now I might be able to even kind of see where they're getting this from. I don't know. Okay, anyways, though, what am I doing? We want to add this to our render somehow. We'll wait to add it to the renderer. What do I have in here? I've got that. Yeah, so this is where it would probably be. We'd have something like draw vector is what I'm guessing, and then we would just like append that vector to a batch and then draw them all in one batch call. So yeah, let's do that. We'll say void draw Bezier. That will take in const vec2, p0, const vec2, p1, 2, p2. So those will be that, and we'll take in a style just to match with all of those, and then we'll go into render.cpp and we'll go ahead and implement this below draw filled triangle. Okay, so we'll go down here and we'll just have this, and I'll set it all up because I do anticipate this being kind of like the API. We might have to add like one more bool or something, but that's not that bad. And then we'll have a struct vector vertex. This will be a vec2, which is our position, and then a vec2, or no, a vec4, which is our color, then a vec2, which is just our UV. So we will have that, and we will do static vertex vector, or vector vertices, max number of vertices per batch. So it'll use the same thing. Do we have like a counter? Yeah, we do. So then we'll have like a static uint32, vector VAO, VBO, vector number verts. Okay, so we'll have all that stuff. That's good. Okay, so set up screen VAO. Yeah, we don't care about that. Set up batched VAO. Okay, cool. So we do care about that. We'll do another one up here. We'll call that set up batched vertex or vector VAO, and then we'll copy this, and it'll be basically the same. Okay, so we'll say create the batch VAO. Allocate space for the batched VAO. Yep, that all looks good, except we want to do vector VAO and vector VBO. And that's all good. And we do not need an EBO. We probably don't want an EBO because this stuff is all dynamic. So yeah, we can't reuse those because it will change from primitive to primitive. Okay, so we're definitely not going to do that. 0, 1, 2. So we're just going to change that one. We only have 3 of these, and this is going to be 2 floats. And for that, we can get rid of that. And then non-normalized, and this will be, I think I just called it UV, vector vertex. Yeah, I did. Okay. Vector vertex color, and then vector vertex position. Okay, so that should set it up. We're all good there, and then we can just add to it however we're adding in the other place. Okay, and then we need another shader, so we'll say, which we forgot to do. So we got shaders up here. So we will add static shader, vector shader. All right, I'll put that right there. We will compile that down here with the other shaders. Vector shader dot compile assets slash shaders, and I think I just called it vector shader dot glsl. Okay, and then we'll set up the batched, and then we will set up vector batched or batched vector, and then we should be good. So now we have all that flush batch. I don't think I ever free anything. This is like a personal library right now, so yeah. That's why there's a lot of kind of oddities. Flush batch, so we don't really do one draw call, so there's no sorting. I may have to change that so we can sort things, because that's going to be an important feature eventually. So for now, this just flushes it, but we can fix that. Okay. I wonder, this is kind of a tangent, but I wonder if you even need to do sort of sorting, because I know you can do like custom Z comparisons for OpenGL, or like depth comparisons. And so I wonder if you could do like a Z index in a 2D renderer and then use that as your depth comparison, right? So that if you're like, you can just render everything one pass, and then if something is in front of something else, you can discard a pixel based on the depth just by like checking your custom depth comparator. Yeah, that would, you could probably do that, but that still doesn't fix blending. So for that, then you'd have to do like order independent transparency thing. Okay, never mind. Tangent done. But that's just something I'm curious about. Okay, so we do this stuff. This calls flush batch. This calls screen shader bind, texture. We bind the texture. And then we just do the draw call. Okay, so that just does the draw call. What does flush batch do? Okay, so that just does a draw call too. Gotcha. Yeah, this is probably not the best way to do this, because if we render the frame buffer, we it looks like we're not flushing the batch every frame. That's probably why we weren't seeing anything too. Let me just try this real quick, because now I'm curious. If I just do flush batch here, will we see stuff now when we do our video output? If so, I don't know why this was broken in the first place, but it was. Okay, I broke something. Unknown shader type. Did I call this wrong? Fragment? Fragment. It's because of that space. A very fragile shader parser thing. Nope, we still have something wrong. We've got a bunch of stuff. Okay, invalid character U in Swizzle. So I guess you can't swizzle UV? Okay. We'll just do XY then. Wait, that should be XX. Y. Okay. Let me get rid of that too. I don't need that anymore. Let's try that one more time. You cannot call render batch in there. Render frame buffers looks like just screen space shader. So I had two separate. So I had two separate things. The render frame buffer is just so that when I'm outputting to a video, I can render it to a frame buffer and then capture that output. So that's what's happening there. I think this should be fine. Implicit cast from int to float. Frag color. Out vec4 frag color. Did I spell that wrong? That's definitely defined. And then it also didn't like this. Okay, let's just fix that stuff real quick. Nope, still bad. Unexpected parenthesis at token parenthesis. OpenGL does not allow suffix F. On versions, what version is it? 330. We'll upgrade that eventually, don't worry. No, this method, just for blit, it just renders the texture to the screen. Look at the method again. Yep, so this just renders to the screen. And then this binds the screen shader. Oh, I see what you're saying. Yeah. Okay, I see what you're saying. Yeah, you're right. Thank you, Sam. Because we're just binding the screen video. Okay, yeah, and then we're uploading the texture. So what is this doing? This is doing texture bind, screen shader upload. Yeah, it looks like this is just rendering the frame buffer to the screen then, I guess. Still doesn't fix these errors that we're getting though. What is up with that? Unexpected parenthesis, expecting colon at token parenthesis. Undefined variable frag color. That's not undefined. We've got it right here. That is so weird. Yeah, that's the same. Frag color. Okay, let's remove that. Oh, maybe it's because I'm using version 330. Out can't be used with non-varying. Oh, did I do out int? No, that's a vec4. Out can't be used with non-varying frag color. What is going on here? I'm defining this correctly, right? Yeah, out vec4 frag color. There's nothing. Oh, I'm missing my. That would help. Okay. I knew I was missing something there. Yeah. We need to tell it what version we're using. I think it's probably using some very old shader version that doesn't support anything. Yeah, okay. That's better. Cool. So, yeah, I still don't get why this doesn't output our video here, though. That's weird. Yeah, we'll have to look into that because that should play the same video that we saw earlier. I think it might be something else then, I guess. But anyways, okay, so that was a tangent. Flush batch, what does that do? That goes down here. So it looks like that flushes this batch. Let's also do the same thing for flush the vector batch. Okay, so then what we'll do is we'll bind a vector VBO. We will literally do the same thing. Size of vector vertices. Okay, we'll upload the U projection. We want to do vector shader. That's fine. Don't care about that. And then vector VAO. And then we want to clear. Okay, so we do that. Okay. Number vector vertices. Number vertices vector. Oh, vector num vertices. I guess that makes sense. And we want to change that to number vector vertices. I did that wrong again. Okay, anyways, so yeah. Oh, no, that's right. Oh, size of takes care of that. Okay, cool. So we should be good there. Yeah, so that should be good. So we've got basically that flushes everything. Now we just need to implement that function, which I still haven't done yet, which we can do basically the same way we do draw filled triangle. So we'll just like check and see if we have enough room. If we don't, we flush. I should really separate those. What a terrible error message. I know, right? It should at least output a warning when you don't specify a GLSL version. Maybe it does. I don't know. How are you saving the video to MP4? Not draw elements since you don't use indices. Oh, thank you. That's a good point, too. How am I saving to MP4 with FFmpeg? And it is a nightmare. I can show you guys in a second, but it is very scary. Why am I doing max too? I should just be doing the number. I don't know. I'll leave that for now though. Okay, so GL draw triangles. I think I have to do 0 than that, right? Yeah. So that's 0 to that. Okay. But the way it works is this video writer thing, and there's like no documentation on this stuff at all. So I'm not touching this. I got it to work and I'm keeping it in this way now. So basically I might change this up so that we can do like low res and high res, whatever. I'm experimenting with stuff. But basically we get like the FPS, you specify that, the width and the height of the output video. I will also switch this so that we can output 4K. And then we get the bit rate. I'm still not entirely sure what that means because I didn't look too deep into this stuff. But then we get to this start encoding file thing, which is adapted from the Stack Overflow question because there's no documentation. And then we do all this weird stuff to initialize things. We create an output format, which we guess the format based on the output file's name, which is if it has MP4, it's going to guess a format for MP4 stuff. Then we allocate the output context, and then we try to find a codec for this stuff. If we can't find a codec, then we can't create the codec. And then we try to create a new stream, which is like how you begin outputting that stuff. Then we set up the stream using whatever this stuff is. AVPix format YUV 420p is like the pixel format. So this YUV 420p is like matching the way that I'm giving the pixels to it. And then I'm saying encode it using H.264. We get this bitrate stuff. Yeah, it's, like I said, adapted from that Stack Overflow. And then whenever we want to push a frame, we pass it our pixels, which are a very specific format for this thing. Then we check and see. So we make sure that this is like the appropriate width and height. Because if the pixels don't match that, then we're in a bad place. Then we allocate a frame. This part's actually not that bad. So, and I think I adapted this from their documentation. We specify the format of the pixels, the width and the height of this frame. And then we just say get buffer. So I believe that basically just pushes, wait, no, I guess this just checks to see if there's already a frame. No, I think this pushes it. I don't know. It does something. And then we go this SWS context. Yeah, not sure what that is either. But it does something and we only do it once. So yeah, and then we get the line size. We scale our pixels so that it matches the appropriate size. Oh yeah, then we convert from RGB to YUV. Then we do our frames. So this calculates where to put it. It's been a while since I've looked at this. And then this receive packet, I think, pushes it. Oh no, this codec send frame is what pushes the frame on. And then we receive the packet for the next frame. So like because you have to like feed information forward. Why is line size an array when you only have an element? Probably because I'm passing it. Oh, it's because of what this is expecting, I guess. Because it's expecting a pointer. I don't know. It's expecting a pointer to AV frame. So I guess AV frame is like a type def for something like that. This is probably adapted from some code too. So I just copied it and changed some stuff. But yeah, the reason it's so complicated is because I guess with video encoding, you have to use the data from the last frame and push that data to the next frame to encode like the, what's it called? Like they have like those, it basically figures out what's changed, the deltas between the pixels and stuff, right? And so you need to do all sorts of complicated stuff in order to get that right. Then when you finish encoding, it calls this thing, which basically closes the stream and lets it know that it's done encoding stuff, and then frees everything. So yeah, this is the thing that I'm never going to touch again, except for this stuff. So it worked. And once I got it working after like days of tears and pain, I was like, I am never touching that again. And I've held true to that. So yeah. FFmpeg though, it's a great library. Okay, anyways. So I believe this should be fine. We basically just upload everything to our vector VAO. We do all that stuff. And this should really be, I'm doing this because this is bothering me. We need a way to flush the batches separately. So flush that, that, and that. Oh, and that. Okay, so that's what we're going to do. We're going to put this up by wherever we have our first flush function. Oh, and I guess this is like a public. Yeah, this is a public thing, so we can do that. Nope, I pressed the wrong hotkey there. That's the one I wanted. So we can do that, and then flush batch. Well, I guess we could use that, yeah. Nope, nope, nope. There we go. Okay, and then we'll do that. And what we'll do is, let's go back up to where we had that flush batch, and we'll say flush vector batch. Okay, so then we need to go where we have that draw vector thing, wherever that was, somewhere. Draw string, flush batch, flush vector batch. Guess it's above drawstring. Draw texture, draw Bezier. Okay, there we go. So then right here, we'll call that. And that should be better. Cool. So that's better. I like that. Vector vertices. We need to change all that stuff. We will change all of that. And that will be number vector vertices, or vector num vertices. I don't know why I called it that. But we can switch all that and that. And we have no texture ID. Instead, we have UV. Okay, and so, yeah, I guess, just started thinking about this. So we have P0, P1, P2, and I guess we have UV0, UV1, UV2. We will need those. So and I guess this is probably going to be called by some other function, so I'm not too worried about it being this long function. We might like abstract all this because this is getting kind of big. I might push this all into a structure and fix that, but yeah. You still got one number of vertices there. Do I? Thank you. Ah, good catch. Up there, I totally missed that one. Okay, so this will be, yeah, in the if, uv0 equals, no, this will be uv equals uv0, uv equals uv1, and uv equals uv2. Okay, so this is like basically all we should need to do. The next hard part that we're going to have is this triangulation thing, but we'll not strangulation, triangulation. I don't know. That just popped in my head because thinking about triangulation sounds a lot like strangulation. Anyways, that's not what we're doing. Maybe I'll want to do that to myself after I finish writing this stuff, but we'll see. Okay, so we've got those UVs. Let's call it from how Bezier works. I guess what I'll do is I'll just call it inside this update thing. Maybe well, yeah, I know. I don't know. My brain goes weird stuff, and this is what happens when I'm just like talking on a constant stream. Whatever pops into my head is coming out, guys, and then you're gonna hear the weird stuff that I say. Okay, maybe it's subconscious. Like this problem with Manim and me having to go back into this library, it's just like putting these thoughts into my mind because I'm like, why do I have to even do this? I should be able to just use a library, but I guess not. Okay, anyways, let's go ahead. We will say render. Gabe, what are you gonna do? We're gonna draw Bezier. That's what we're gonna do. So we will pass in. What do our projection look like too? -2, -1. Okay, so we got negatives and stuff. So let's just do like 0. Vec2, 0, 0. So P1 will be Vec2. We'll do 0.5, 0.5. And then P2 will do Vec2, 1.0, 1.0. And I guess these should all be Fs. And this just made me think of something else too. Oh, that was an F. No, okay, never mind. And I guess what we can do is we can literally just copy this. It's gonna be the same thing. For that, and then for the style, we'll just use like style. And then what I'll do is I'll say style equals styles, default style. Okay, so if we were to do this, theoretically, what should happen is at the end of the frame, we should see whatever that is. Thoughts of strangulation. So if I hit F5, okay, we're getting that stuff. We are not getting this. Are we hitting this? We are hitting this. Okay, so we definitely hit that, and we're up to 3 there. Do we hit that? Where is it? Flush vector batch. Do we ever hit this? Yes, we do hit this. Okay, we bind the shader. And then we draw arrays. Yeah, so we should definitely still draw stuff. It's just that we're not seeing it. Trying to think of what could be going wrong here. Let's change this. Let's just increase this like 3.5, just so that we have some more space to work with. And then this will be like 6. Because that could be the problem, is we just have a weird projection and that is not hitting that stuff. Okay, if I hit F5, I am still not seeing it. Okay. Actually, let's do this. I gotta step through this because maybe it's getting called after, before, I don't know. So if I go F10, okay, we jump out of there, and that was sandbox update is what that was. Okay, yeah, and then we go into render, which goes and does that. Okay, so we are doing that in the correct order. So we should see it pop up if it was indeed popping up. What if we just output a solid color? What happens then? Actually, that's probably a good idea. We should have done this from the beginning. So if it's not inside, we probably should say color equals like vec4 1001, just so that we can see like what the inside and outside is, because that'll be useful too. Do we get anything now? Okay, so we are getting the triangle, and that does look correct, but we aren't getting anything inside. So it looks like, for whatever reason, that's not working. And what we say is, it's equal to that is greater than 0. Maybe we should be checking less than 0. Maybe this is just wrong order. Let's try that out and see what happens. F5. Okay. Something's changed because it's not red. But it should be a solid color, and it looks like that's like semi-transparent. Yeah, it's definitely semi-transparent, which is kind of weird. If it's inside, frag color should equal F color, otherwise should equal that. So clearly our GPU gems guys are lying to us or something, because this isn't right. But wait a second, let's read on a little bit more in that article and see what they say. So, using the sign of the result to determine pixel inclusion. For convex curves, a positive result means the pixel's outside the curve, otherwise it's inside. For concave, the test is reversed. So this would be, I think this would be concave, this would be convex. So we should be checking for positive, which is what I was doing the first. Attributes gone wrong. I am kind of wondering that too. Let's pull out render doc real quick. We'll just check and make sure. So we'll do this. I'll update eventually. Let's go ahead and launch this. Okay, and then we want to set our working directory to that. Let's go. Why does it need access to my Wi-Fi? That's weird. Okay, so if I just hit F5 and then we'll do F12 to capture a frame. Let's go ahead and inspect this. Okay, so oh yeah, we do have this all. Okay, let's look at the texture just to see what this does. So this is that. Oh yeah, you can see what I do is I break this stuff up into several different line segments, which is why we have so many batches there. Same with that. And then this is, okay, this is the one we want to look at. So how do I check this stuff again? I remember I did this before. You can actually look at the vertex data somehow. Color pass, do I go into here? No, resource inspector. I stumbled across it one time. Let's see if we can find it. Pipeline tab. Thank you, Sam. I was waiting for Sam to say something because I knew he would know. Pipeline tab. Where is that at? That is... Do I just not have it open? Tools, window, pipeline state. Okay, there we go. So vertex shader. There we go. Thank you, Sam. Vertex shader, rasterizer, fragment shader. Vertex input, I guess, is what we want to look at. So yeah, we are only getting 3 vertices, which makes sense. 0, 0, 0. Right? This is what this says? No, this is just the attributes. But I actually want to look at what the input is. Okay, so if I do that, yeah, that's not what I want either. Pipeline state. Check the mesh view if you need. Thank you. That's what it is. Go button. No? Okay, so this is what we're getting. So for APOs, I do really like this too. So 0, 0, that's right for the first position. Then 3.5. Oh, that's not right. Yeah, bad vertex attributes, definitely, because that should be like 3.5, 3.5, I think, right? Yeah. So what's happening? So we got 2, 4, 2. Okay, so, whoops. Wait. It's not right, but it is giving the right triangle there. Oh, wait, no, 0. Yeah, well, no, yeah, that should be 3.5, 3.5. Weird. I guess it looks correct, but it's not. Okay, let's go ahead. We'll close this out, because I think we now have the source of our problem. Then we'll close that out and that out. So I clearly set something up wrong here. Batched VAO. The color is weird. It's not the same. Yeah, that's true too. The color is changing, which was another thing that I thought was strange. So we definitely have something screwed up here. So this is 2 floats, and then we get 4 floats, and then we get 2 floats. And this should be offset that, offset that. Oh, this is why. Yup, I knew I was missing something there, and that is wrong too. Okay, well, let's see what happens now. Maybe the GPU gem guys weren't lying to us. Okay, we're not getting anything again. Which is weird, because we should be getting red or something at least. Like, we shouldn't just be getting nothing. Did I switch this? I did. Let's change this back to greater. F5? Okay, yeah, it still doesn't make sense. We should still be getting something at least. Let's see. Let's match one of those Bezier curves, and we'll see what they look like, just to make sure we're not, like, going off the screen. Yeah, so P0 is -2, -1, 0, 2, 2, -1. Okay, so I guess there's potential that, yeah, that it is off the frame buffer. Maybe it's copied wrong too. That is true. We'll check that real quick. Okay, so when we draw, that's all correct. P0 style color, UV0, P1 style color, UV1. Yep, that's correct. Vector VBO, vector vertices, we upload it, and we're just using the size of here, so that should be fine. Yeah, I know, that's what I was just about to say. We're going to open up render doc again. Let's go ahead and we're going to do this. So let's go to application. Should have left it open. Okay, animations. At least it saves like the state, but I think that's a Windows thing. I don't think that's a render doc thing. Okay, so let's go do that. We'll say F5 and then we'll say F12, capture that frame, go here. And we'll go down to here, pipeline, mesh. Okay, so we're 0, 0, 3.5, 3.5, 6, 6. So that is correct. The color looks correct as well. The UVs look correct. Okay, so we are getting the right values in here. There's nothing wrong with that. Warlock, hello. On May 23rd, I'll give you... Ah, nice. Wait. Oh, I thought you were... for a second, I thought you were one of the spam bots or something because of the way you phrased that. On May 23rd, I'll give you my Prime subscription. You probably won't be online and you might not get it. Well, thank you, Warlock. That is... I appreciate that. Sorry for thinking you were a spam bot. The way you phrased that just seemed very much like the way all the other spam bots say that and stuff too. Wait, Sam, camera is there. Sorry. Oh, same. Okay, yeah. Yeah, so we're definitely uploading projection and view. we are definitely saying that correctly. FUV, F color. Yeah, so those are definitely getting set correctly. That's getting set correctly. What if we just do frag color? What if we just do that? Do we get, because we should at least get a triangle. Yeah, and we're not even getting a triangle here. So what's up with that? Is it just because of the way that I have the vertices? Let's make this like negative 2 0.5, and then we'll make that 3. Okay, let's see if that changes anything. I don't know. I don't think it is that, but because you'd still, okay, yeah, now we know it's definitely in the same range as these two lines, and we're still not seeing anything. We should at least be seeing a red color. Okay, so there's definitely something wrong here. Let's put a breakpoint here. Let's see if we're getting anything. Try disable culling. That's a good idea too. If it's in reverse order, that is true. Although I don't think I would have that turned on because this was just a 2D thing anyway, so I don't think I ever bothered turning it on, but let's see. That's weird. Oh, that's because I turned on cull face. Yeah, so face culling was never on to begin with. It looks like we have some of those facing the camera and some of those facing not the camera. So yeah, let's put a breakpoint here real quick, and let's just make sure that I'm actually getting vertices here. Okay, so we get 0 vertices. Okay, so we're not getting any vertices for some reason. Why is that not happening? Are we not hitting this? Why are we not hitting that now? Okay. Something changed, I guess, where we're not even going into here. Did I change something? Let's see, if I hit F5, we go into here. We go into here. Okay, so we definitely hit that. Thank you for following. Nicole is man 78. Nicholas man, maybe? That makes more sense. Thank you for following. Good to see you. Okay, so if we go flush vector batch, that says 3 now. Okay. What if we go through again? Yeah, that looks right. And Boy Bay Killer, thank you for following. Good to see you. I've seen you in Discord a lot, so didn't know you were attending the streams too. Pretty cool. Okay, let's see if we go into here. Yeah, 3. Okay, so why in the world was I getting... Oh, you know what it is? I think it's because we call flush twice. So 3, 3, 3. Okay, no, it's just calling it once. Are we... Okay, there's still nothing there. Why were we seeing 0 a second ago? Did I like accidentally step past it or something? Okay. Anyways, so that's fine now. I guess that wasn't the problem. Okay, that is the vector shader. Look at the attributes again. Yeah, that was what I was going to do next because something is clearly up. So vector, 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 vector. That's fine. Yeah, that's fine. So we say 0, 2 floats. Is there obvious information in MVP matrices that can be read out easily? Model view projection. Not in the model view projection, no. There is in other things, though. But I don't think it's the model view projection, though, because we're doing the exact same calculation here that we're doing in here. Yeah, that's the exact same calculation. It's getting the same projection matrices, too, and nearly the same positions. So I definitely don't think it's that. I think, like Sam is saying, we know the vertex attributes are correct, too, though, because we checked it in render doc, and it was getting the correct position, color, and UVs. Which implies that that's correct. Yeah, yeah, that implies that it's the correct. What the heck? That is weird. Were there some errors? Oh, were there some errors in render doc? I don't know. I didn't even check, did I? Oh, yeah, there were. Voxel riffs, you didn't say that earlier. What is this saying? If I click the capture, 4 issues, 4 unread. How do I check the issues? There we go. Buffer object bound. We'll use video memory as source. Okay, so that's not really an error. That's just saying it's going to use video memory. Yeah. Yeah, because if we look at, like, this is definitely all correct. The last time we thought the error was not an error, it was an error. Let me see. Maybe it's this. Something wrong going here? Maybe we are executing everything. Well, no, that wouldn't matter anyways because I'm resetting it at the end there. Yeah, that wouldn't do anything anyways because just have this. Is it this? Is it because we're outputting to the wrong thing? Yeah, are we like not bound to the correct thing or something? This is really weird. Because it should just work. Or at least we should see a triangle. So this would be 0. Then we increase 1. Then we increase 2. Am I using the default render buffer? That's what I was wondering too, but I should be, because if we look at the render function, I'm doing these like, so this is going, then this is going. And this doesn't set any GL state, I don't think. Yeah. So if this is drawing to the buffer, we should see that too, like to the same frame buffer or intermediate frame buffer. Yeah, I wouldn't think so because these are going at the same time. So if they're going at the same time, then we should see the same output. And I mean, we can also check in here too real quick. If we just go, where is it? Yeah, in here. So we can see that's getting called here. And what happens is we go that, then that. Yeah, this basically goes through and does all the animations. What if we were to do this and then that? Does that change anything? Are you sure the view and projection are being computed properly and in the same way in both functions? I believe they are. We'll check again though. I mean, we were seeing a triangle just a second ago when we had the vertex information wrong, which is what really confuses me. Yeah, we can check that for the order of commands. And that's what, like, this says bind buffer, buffer data, use program. Wait. Bind vertex array 58. Oh yeah, that's fine, because that's a buffer, 59, 58. Yeah, that makes sense. This is weird. This is very weird. We're getting correct vertex information, and it was drawing a triangle a second ago, which is why I'm very confused. Vertex shader in, vertex shader out, ds out. Yeah, okay, this is right. And it's saying we're getting these. RG, RGBA, RG. Yep, stride. 32, is that right? Strides, that's 4, 8, 12, 16, 20, 24, 28, 32. Yeah, that's correct. Offset 0, 8, 24. Okay. So those all look correct. Do you see triangle mesh in the mesh VS shader? Is that mesh viewer? No, we don't see a triangle here. Wait, here. We see a line. Whoops. Yeah, I just see this line. That's weird. Solid color. You clicked VS out. Click VS in. Oh. What if I do solid color? It's not shading anything. Like, I'm not seeing... Maybe you did the wrong vertices? Highlight vertices. I don't know how this works, render doc. It's just highlighting one vertice. Wait, am I using APOS? Is that the problem? Wait a second. Okay, yeah, I'm using that here. X equals Y is a line. The vertex coordinates are on the X equals Y. Oh. Oh. That is 100% correct. So, oh man, that is annoying. -2, 0.5, 3.0. Is that all on the line too? So should this be 0? Or I guess we should do -2. Oh man, voxel riffs, thank you. Wow. Okay, so nothing was wrong. There was nothing wrong. It was just that I somehow picked vertices that were on a line, because in my mind, I thought I was doing this, but when I was really doing a line. Okay, that's great. Thank you, voxel riffs, for paying attention to the stuff that we all should have been paying attention to. Man. That's a new one. I've never had that happen before, but I guess now we know what happens if you try to render a line in OpenGL. That should be a triangle. Okay, so this is still wrong, though. That's sad. Well, actually, I guess technically, since this is all on a line too, because I copied this. So if we do this as 0, does that work? Let's see. All right, guys, look at that. Look at that. It is indeed rendering a spline. Let's try and copy what they've got, because I just want to make sure this is absolutely 100% correct. So they've got 0, 1 half 0, 1 1. Let's see if we can copy that. This is great, though. So finally, I wonder when one person will get every single bug in OpenGL in their life, even though this wasn't really a bug. Yeah, was that a feature or was that a bug? We shall never know. Okay, 0, 0, 1 half 0. 0, 0, 1 half 0, and then 1, 1. Okay, so if we do that, and then what do their vertices look like? It's kind of like the same deal there. So I guess what we'll do is we'll just say -2 is our 0, 0, and then what? 1 half 0. That would be -2. And then 1, 1, we'll just say is like 3, 3. So if we do this, we should see like the same kind of thing they got there. Okay, which we do. And is that... Okay, we've got it reversed though. So if I reverse the order in here, we say that's a less than instead. And let's just remove this for now, because we'll do this for now. Can we do like 0.5? Do I have blending on? 0.2? Because I would still like to see the outside edges. Those will be good when we actually get to debugging more complicated stuff. But yeah. Okay, cool. I do have blending on. Cool. Look at that. So this is definitely working. Success. Okay, we've gotten at least one part done. Now what we need to do is triangulate a series of vector curves into something like this. And then we've got very cheap vector rendering on the GPU. Like, this is not an expensive calculation. Multiple, like, lighting calculations are way more expensive than this. This is just like an addition, multiplication, and comparison. So yeah, that's pretty cool. Sam, so if you do distance to 0, you can get a line in the shader. Yeah, exactly. And that's just how Bezier curves work in general. Like if I have my draw line, I think I use a Bezier. Do I? No, I do not. Okay. But yeah, so if we were to do... So if you do distance to 0, you can get a line. Oh, so are you saying if I can do like if this equals 0? You'll have to expand on that a little bit more. I know basically if you have 3 Bezier points that line up, that should be a line, but we don't have any depth here, so I can't really do that. But let's see what they say now. So we've done this part. That does indeed work. We're not going to worry about cubic splines for now. Maybe one day. But that is a lot of complicated math, as you can see, and I don't feel like dealing with that. Okay, so triangulation. Our triangulation procedure, that'd be too thin. Exactly, yeah, you'd need like 2. So it makes more sense to just do a quad at that point. Yeah, you'd get the same number of vertices, and that's the same runtime complexity and all that stuff. So yeah. Okay, our triangulation procedure was only briefly discussed in sections 25.2 and 25.3 in the interest of simplicity. An important detail not previously mentioned is that Bezier convex holes cannot overlap. There are 2 reasons for this. One is that overlapping triangles cause problems for triangulation code. The other is that unwanted portions of one filled region might show through to other, resulting in a visual artifact. The problem can be resolved by subdividing one of the offending curves so that the Bezier convex holes no longer overlap. Yeah, but should this not, like, curve around it? Like, should this not like go there and then, yeah, shouldn't it look like that? Or not? I don't know. We locally triangulate all non-overlapping Bezier convex holes. For quadratics, the Bezier convex hole is uniquely a triangle. For cubics, it may be a quad or a triangle. If it is a quad, we triangulate by choosing either diagonal. Next, the interior of the boundary is triangulated. The details of this procedure are beyond the scope of this chapter. Any triangulation procedure for a multi-contour polygon will work. So they're not even going to talk about the triangulation procedures. That's great. Okay, so let's take a closer look at this. Can I not blow that image up? It's supposed to be doing some JavaScript there. It says JavaScript to pop up in the bottom left corner of my screen, but their JavaScript is broken because it's not doing anything. Okay, we'll zoom in. So basically, this is how the letter E would look. And this is how they're triangulating it. So they have like, this is one vector. Then they have like a regular triangle here. No. So this is one Bezier curve, right? And then the second Bezier curve would be this. No, it would be this. I think there's like 3 Bezier curves going on here, right? So we've got this one. That one's pretty easy to see, right? So this gets us this. And then they have a triangle in between the Bezier curves, right? We've got 1, 2, 3 triangles there. And then this is the inside Bezier curve, which is like the interior points here. And this fills in this portion. So it looks like what we need to do is we need to basically get the outer edge and the inner edge, which we already have from the font file. And then we need to somehow get these in between triangles. Do we get those for free though? No. That's just going to give us that. Okay, yeah. So I guess what we can do is we'll do the easy part first, which is let's see if we can get like the outside edges and the inside edges, and then we'll fill in the in-between if we can indeed get those. I wonder if FreeType, we're using FreeType. FreeType, get a vector outline. Yeah, getting the vector points of a letter in a TrueType font. Use the get glyph outline, GGO native option. This is Microsoft though. I don't think this is, what? Guys, I wrote a whole stupid font rendering library and it turns out Microsoft. Okay, that's not cool. Apparently, you don't need to write your own font rendering library because you can just use Windows WinGDI. Although I don't know how fast or slow that is, but wow, that's disappointing. Okay, FreeType tutorial 2, glyph metrics. Width, height, horizontal bearing, all that stuff. Yes. Managing glyph images, transforming, copying the glyph image, measuring the glyph image, converting it to a bitmap, metrics, scaled global metrics, kerning. So we will still all need like that information and stuff, which we can use. But what I'm interested is if we can get the actual underlying representation, which I imagine they would give it to us, right? If you want to do extra stuff. Accessing design metrics. You can access glyph metrics for font units. Okay, that's not what I'm interested in though. Conclusion. Let's see if they have, yeah, documentation. Okay. Glyph conventions, FAQ, API. Let's check the API. Okay, so we got the core API, which has all that. Format specific API. See, font rendering is just this rabbit hole that you can go down forever. And I actually really enjoy this stuff. I don't know. This is probably a complete waste of time, but I think it's fun. Win API, what? Yeah, I know. Does Linux have a font rendering API as well? If not, it would still be useful to make your own. Exactly. So if Linux doesn't have it, although I imagine they would, No, actually, I don't know. Yeah. Let's see. True type tables, type 1 tables. We might want to go to the table. Horizontal header. Okay, so we got the vert header to the header. It's been a while since I've looked at this stuff, but that's not what we want. What about type 1 tables? Font info. Yes, this might be what we want. No. What about font formats? No. I know there are true type tables that give you the stuff that we want. It's called like Glyph though, and that contains the actual Bezier curves. But it looks like they're not showing that, because if we look at if we look here, we can go and somewhat. Okay, here we go. OpenType spec, which OpenType is basically the same as TrueType. It's, you can use them because they talk about TrueType in here, I think. Yes. Okay. Yeah, TrueType fundamentals. See, they have all this stuff. And then somewhere in there, they have all the tables. There we go. This is what I was looking for. Okay, yeah, so we've got this glyph table. Sam, I think it should be in core glyph. Oh, that would make sense. Core glyph. Yeah, that would make sense. Glyph management. Yeah, outline glyph. A handle to an object used to model an outline glyph. This is a subclass of FT glyph and a pointer to FT outline glyph. Rect. Define FT glyph. Root outline. What is outline look like? Number of contours, number of points, tags, contours, flags. The number of contours in the outline. Okay, so this is like one contour is this outer outline, and then this inner outline is a second contour. So those are contours, which you can also read about here, right? Because this is mirroring this number of contours. Oh, and then you also have composite glyphs. Those are interesting too, which we'd actually have to take a look at because math symbols have a lot of composite type glyphs. Okay. Anyways, though, number of points in the outline, and then points, a pointer to an array of endpoints, FT vector elements, giving the outline's point coordinates. Tags, a pointer to an array of endpoints, chars, giving each outline 0. It's off. Well, 1, it is on if set. Bit 1, meaningful for off points only. If set, it indicates a third order Bezier arc control point and second order control point if unset. If bit 2 is set, 5 to 7 contains the dropout mode. Oof. 3 and 4 are reserved for internal purposes. Okay, and then contours. An array of contour shorts giving the endpoint of each contour. The first contour is defined by the points 0 to contours 0. The second one is defined by the 0 plus 1 to contours 1, etc. Could you somehow use LaTeX for all this? Probably. But the reason I'm not using LaTeX is probably the same. I don't know, does LaTeX? Yeah, it looks like it doesn't have GPU acceleration. And I think that's one of the main problems with the Manim library right now, and that's why when you use OpenGL, it doesn't speed things up for the rendering. Like, the whole point of this is that I want the real-time rendering so that I can do real-time editing and stuff. So I don't think using LaTeX itself would actually be beneficial for us. Yeah. And this stuff, it sounds complicated, but it's not that bad. And I'm wondering, because I had something here that I've done a while ago. So somewhere down here, TrueType parser. There we go. I think I have. Let's see what this does. Because I remember when I was testing stuff, I was using drawing stuff exactly according to the TrueType specs and stuff. Could you somehow use LaTeX? Makes sense. Hold up. Did you really search for Raid Shadows Legends? Hello? Did I do that? I don't see Raid Shadow Legends showing up when I type in RA. I? D? No? What did I search that pulled that up? Because I don't remember searching for that. No. If I ever did a sponsor, it'd be for something that I actually like to use and stuff. But yeah. Yeah, okay, you can see that I literally have like this stuff here, which was the exact same format as that. Number contours, contour ends, number points, flags, X chords, Y chords. Yeah. So I wonder if I have it in here somewhere. Glyph.cpp, get glyph ID, get glyph, parametric. Yeah, okay, here we go. So calculate winding number, draw simple glyph. Okay, so this is how you would go about drawing the glyph. So we get the scale, the width, height, the font width, the font height, canvas width, and the canvas height. Okay. And then I get a file output, and then we go through the canvas height and the canvas width. We get the winding number, which we calculate doing some magic. Okay, and then I think this calculate winding number is basically where we use all this stuff. So then we use the number of points, the flags, X chords, Y chords. So then this calculate winding number, Okay, here we go. Then we get the contour end, the contour begin. So we loop through all the contours. And then we check the flags. Yeah, and then you can see here is the flag for on curve point. So if 2 on points means it's a straight line, on point, off point, on point is a standard Bezier curve. Yeah, so this is literally exactly what they're talking about here. So this is kind of what we have to do. Must be another ad they got offered too. I guess so. This is a bit more involved than we actually need though. Let's see if we can just, let's do this. Okay, so if we go into font.cpp, which I do have somewhere in here. Okay, so if we go into here, okay, so this gets the font, we get a face. Okay, we set the char size, all that stuff. How do we get this guy, which is the FT outline? This section contains routines to create and destroy scalable glyph images known as outlines. These can also be measured, transformed, and okay. I'm just kind of looking through this stuff. What does decompose do? Yeah. There's a lot of stuff with fonts, which is one of the reasons I never did this, because it's just there's so many edge cases. Quick retrieval of advanced values. What's this? Okay, no, that's just, yeah, we don't care about that. What's list processing? Because if we could, like, if they have a structure that basically just makes it a lot easier to go through this stuff, that would be cool. A structure used to hold a simple doubly linked list. Previous next data. Okay, this is just a linked list. Yeah, okay, so that's nothing of value. Computations, what is this? Okay, that's just math. Okay, so it looks like this is our best bet, is this FT outline. So how do we get the FT outline? FreeType, get FT outline. One time I did my font running with FreeType, but I would not go to that rabbit hole to draw the font from plane curves. The plane curves part actually isn't that bad, as we just saw. Like, that's just a triangle. You know, the hard part is just getting that information out of the font. That is the hardest part. Okay, yeah, so outline curve decomposition. Yeah, and like there's a ton of notes. Like, this is all about how to use this stuff. Oh, and it looks like they do support quadratic. Or is that cubic? That's a cubic spline, I guess. Is that? No, that's, yeah, that's a cubic. It has 5 points, but cubic. Yeah. FreeType outline is described through FT outline. Right now, the following fields of interest are this. Here, points. Okay. Bounding and control box computations as described. Bounding box, such a situation. Okay, how do we get the outline, though? To traverse these points in a callback-based manner. Ooh, okay, here we go. Note that each ooh, okay, so this FT outline decompose, we basically give it a callback, and then this gives us a pointer to the source target, and out a typeless pointer that's passed to each emitter during the composition. It can be used to store state. To generate contours, segments, and Bezier arcs may be reported. In most cases, okay. A pointer to the source target. A table of emitters, function pointers called during composition to indicate path operations. Okay, but what's, where's the actual, oh, wait, okay, I think I see what it's saying. So this FT outline decomposed to traverse these points in a callback-based manner. Wait, okay, contours is an array of point indices to delimit contours in the outline. For example, the first contour always starts at point 0 and ends at point contours 0. To traverse these points in a callback-based manner, use this. Note that each contour is closed. FreeType. Traverse contour points. Loci. Gabe, I accidentally made a color invert shader while missing our shaders. Nice. See, I love this comment in their code. All the edge cases in the fonts, they're just like, yeah, this actually does happen, because you see that stuff and you're like, why that? Anyway, why do I want to make it since you can just draw the font normally? I want to make it so that we have, as I talked about in the beginning of the video, so we can draw the outline first and do cool animations and stuff. That's basically the point of what this is all about. Let's see how they use it. Okay, so what do you want to draw it with curves and not just do the bitmap? It's because there's an animation in... Manim that draws the outline and then fills it in. Yeah, yep. That's what I'm trying to do. Yep. That's the whole point. We're doing it this way. And then plus I can extend this to regular scalable vector graphics and do cool animations like that and everything. Basically iterate from 0 to contour 0 and contour 0 plus 1 to contour 1. Yeah, I think that's right. It's just for 2 contours. Yeah. They got go-to statements in here and everything. Oh, wait, no, this is a case? Well, no, that's a case, and then that's just a label. Okay, so for n equals 0 until it's less than the number contours, last. Like, I would like it if I could use their traverser thing, but I don't know what it's returning you. Like, if I could see an example of how to use that. Let's do decompose, because that's what they called it. Does it say it somewhere down here a little bit further? Bounding box, computation, coordinates, scaling, grid fitting. No, they do not. Is it in here? Glyph outlines. Pixels, points, device resolutions. Okay, vectorial representation. Hinting. No, they don't say it there either. Okay, I guess we're just going to use this straight up. Still don't know how to get the outline though, which would be helpful. Is it contained in here somewhere? ft get outline. ft outline. How do we get the face, the font face? So what do? We say new face, set char size. Then we do this. Get char index. Okay, so we get a glyph index. We load the glyph. And then we rendered the glyph. Okay, I know, but can we do get glyph outline? Because that's what I want to do. Can we say ft glyph? Yeah, I would expect there just to be like an ft get glyph outline or something. ft render glyph, ft this is the closest thing, but this is just a macro. What does it expand to? ft glyph format outline. Yeah, that's not what I want. FreeType get glyph outline. So we give it the glyph. Yeah, that's the outline glyph. That's what I want. Okay, get glyph index. Okay, so what do? They get the font name. That's fine. They set the char size. Okay, get the glyph index. We've done all that. And then they load the glyph. We have that. Okay, then we get the glyph. Okay, then they get the glyph. Okay, ouchie. Get outline. Glyph ouchie. So get outline. Oh, and they have a print outline too. Ooh, okay. This is good. We just found the gold mine, guys. Okay, this is going to help us finish. So yeah, let's do that. Let's copy all this. This is what we'll use. Okay, I'm ready to contribute. What do you need, Gabe? Thank you, SC Woods. We will see. I need to understand this is what I need. And I did at one point, but not anymore. Let's go ahead and just move those to the top of the file for now. Okay, so get outline goes, it gets the glyph. If it's a bitmap, it just errors. Otherwise, they just cast it to a glyph. Wow. Wow. If only I would have known how hard it was. That's great. So you can just... Okay. Cool. So we have this check thing, which just checks for errors, I guess. What is this saying? Why is this not happy? Unannotated follow through between switch labels. Will that make you happy? Prefer enum class. I can't do that. Okay. Yeah, that didn't make that happy. Okay, so print outline. Start index, end index, contour. Let's see what this does. So basically, if we just give it a glyph and then an outline, we should be able to do something with that. Let's go font.h, fonts.h, and we will call this void test outline. Okay, so that's what we'll do. Then we'll move this over here. Let's do that right there. Okay, and then let's go ahead. We're going to do basically the same stuff. Well, not that stuff. Basically the same stuff we did in here, except we'll remove stuff we don't need. Don't need that. Face, we get the face. I guess we do need a file path. Okay, so const char start file path. And we also need a glyph. We'll do a char for our glyph or our character. We'll call that. So we get the face. Okay, we return if we have errors. Font size. I guess the font size matters. I don't think it matters too much though. Int font size. Yeah, we'll do that. Okay, then we don't need this. Don't need that. Okay, and then we need that. Generate default char set. Okay, so then we'll just grab all this stuff. And we will swap some of that stuff out. Okay, so we don't need to allocate any memory here, at least for now. So this goes first char code to last char code. Okay, so basically it's just converting the ASCII code to char code. So we'll just call that UN32 character. Glyph index. That. And this is going to be face. Okay, so then we get the glyph index. If it's not found, we do that. We should probably do that as a character too. I think C is character, right? Okay, anyways, then we load the glyph. Okay, we're not going to render the glyph, so we can ignore all this stuff. Okay. So we can do that. That and that. Okay, cool. That should be C, character. And finally, what do? We want to say print outline. Well, I guess we need to say get outline, then print outline. We'll give it our glyph, which we've gotten. At least I thought we had. We've loaded a glyph. ft get glyph. Yeah, okay, there we go. So we'll get the glyph. Glyph slot. What is our glyph slot? It's just 0, right? I think. ft load glyph. What does this do? Function load glyph description loads a glyph into the glyph slot of a face object. Oh, so I guess we just use our face glyph slot. Oh, there we go. There's the glyph. It's just face glyph. Okay. So face glyph, which is a glyph slot. Okay. Oh, wait, that's a glyph slot. Okay. So wait a second. So get glyph, face glyph, and then the out glyph. That's that. I guess we'll just call that glyph. ft glyph star glyph. We'll just call that that. Okay, so we get the glyph, and then we want to give it our outline. Okay, so that's that. ft outline glyph that, and then we'll say print outline and we'll say that, and we'll say could not get outline for that. Okay, so we'll see what happens. All good. Weather is crazy nice on the side of the planet. That's why you #if0 your code. Weather is crazy nice. It's like 90 degrees here right now, which I actually don't mind that much. I grew up in a tropical area, so I guess, yeah. Just like I say tropical area, it was a hot and humid area, so that's where I grew up. That's why you #if0 your code instead of deleting immediately. That is true. Okay, so we just need to clean that up. Let's do that. That. And there we go. Cool. So let's put a breakpoint here. Let's go into here. I guess, yeah, we'll just do it in main. What the heck? It doesn't matter. Let's say #include. That's not include. Fonts, or I guess render. What did I call it? Render? Yeah. / fonts. Okay. That's, yeah. We'll say fonts low or test outline assets / fonts / what do I have? I'm hoping I have something in here. If not, we can just, we do not have anything. Okay. So what we'll do instead was we'll say C / windows / fonts / fonts. Let's do this one. This looks pretty easy. So we'll start with a simple one. Let's see. Can I see? Okay, so that's just Baskerville.ttf. Is that actually where it is though? Yeah, because I hate this view. I don't know why Windows decided to do this. Yeah, I think that is what it is. So it's just that. So we just do that. That is the font file. Character will be, we'll do a lowercase a. Actually, let's do a capital B because that has 3 contours. So somewhat complicated. Okay, and then font size we will do is like 32. Don't know what that's going to do. And we'll put a breakpoint there. Let's see what happens, guys. We should see it print out the outline, hopefully. Oh, error. Redefinition, multiple initialization. That is true. Another error. Redefinition again. Man. There's going to be another one. Yep. Okay. No. Okay. What's this say? Unload font. Already has body. Did I do something weird? Did I do something weird? Unload font already has body. Yep, those are 2 different functions. Am I missing like a closing bracket somewhere? Wait, let's scroll down to the bottom of the file. No. 2 unload methods. Yeah, there is 2 unload methods, but they have different declarations, right? Void unload font star. Void unload font char star font size. Like, that's definitely on purpose. Oh, wait. Okay, there's 2 of those. Wait, what? And they're exactly the same? Oh, did I? Okay, I think I accidentally copied it. Okay. When I was copying everything else. That makes sense. Okay. There we go. That confused me to no end. That works now, though. Sweet. So, oh, we get an assertion immediately. What is that? Mutex destroyed while busy. What? Oh, it's not initialized. That makes sense. Okay, let's move this out of main. Can't do that till we've initialized stuff. So fonts init, we'll do it in here. Then let's get rid of this. Okay, so, and then let's go back into their breakpoint. Okay. So we go in here, new face. Okay, all good. Okay, all good. So we've got our glyph. Let's see what happens then, I guess. No errors. Okay, what happened when we print outline? Ooh, look at that, guys. Okay, so we've got point 0 is x204, y is 0, flag is EA0. Okay, so these flags are just bit representations. I'm not sure why they're printing out characters there. At least they should be bit representations, because then we get 0010, which is what I'd expect. 9100 100 AA. What is A? What is E? What is 9? 0 means off point, 1 means on point. And this is contour 0. We get contour 1, contour 2, which is correct. We should have 3 contours. Let's look at those flags again. Flags. Let's see. Outline. Okay. Outline masks. It's an int. Okay. So I don't get why they're rendering that. It's that. And then it just says a set of bit flags used to characterize the outline and give hints to the scan converter on how see outline max or outline. Okay, so we've got outline none, outline owner, even odd fill, reverse fill, ignore dropouts, smart dropouts, include stubs, outline overlap, high precision, single pass. Boy, that's a lot of stuff. These constants are deprecated. Use the corresponding outline. Okay, so these are the ones we want to use, and they have quite a few here. Let me check that function. What is he doing to print these? Okay, where's he getting flag? Flag equals CH. CH equals P flag plus 0. Oh, okay. I see what's happening now. Yeah, I don't get why he decided to do that. We should just be doing P flag, which is a char star, pointer to flag, which is just a byte. Like, I think that's just meant to be a byte. So let's, instead of doing that, we'll just say int P flag, which should give us, actually, let's do this as a hexadecimal. Yeah, see, this is why I don't like this stuff. Why are you doing this? That's what I want. Thank you. Okay, let's change this up, though, because I want to actually format this. Printf point. Okay, so point I. That will be a %d. Point p x equals And then he has x, which is also a number. And then he has space y equals %d. And then he has space flag, whoops, equals. And then we will do %d. Okay, that's, or actually we'll do hexadecimal. So we'll do 0x %. Oh wait, okay, I always forget this. Print hexadecimal. C. Always forget this. Okay, %x, yes. So I do the 0x prefix just because that helps me. So 0x %x, just so that you can tell it's a hexadecimal character. Anyways, though, that's besides the point. P point x, P point y, star P flag. Int. Okay. And that. And let's actually glogger info. Okay, and we should be able to comment that out. Whoops, let's redo that. I guess that's what I meant to do. Totally. Okay, let's go ahead. Continue. F10. So there we go. This makes much more sense now. Okay. Maybe I should have left that printf. Okay, I changed my mind. Let's change this back to a printf real quick because the logs are a bit much. And then we'll just do a /n here. I promise we're like this close to rendering the fonts. Once we get this all settled, we're basically there. Okay, so 0x35. If we look back at this, there is no 0x35. So what is going on there? Wait, and we just get 0x35 every single time. Okay, so something's clearly going wrong there. Because we know those are different. So he was saying star P flag plus the character 0. So maybe that's what we need? Yeah, and that would make sense too. I think we were probably also getting corrupted data because of that. Okay. It's multiple flags. Is it multiple flags? I think we were just missing that ++. There we go. Yeah. So this is right now. Wait, no. So we get 3511001009. Which this makes sense. Let's do ASCII. Because remember, the first one was like E or A or something. ASCII to text. Wait, no. I want... Yeah, actually, I think this is right. So 0x35. What is that? 0x35. All right, let's do hex to ask that. Makes more sense. Okay. 0x35. Convert. Maybe I should get rid of this x. That's 5. Oh, wait, but he was doing +0. It's a bit set. Wait, okay. So yeah, the +0 is just so he can show it as characters. I don't know why. You can get 0x35 since there could be multiple flags inside. Oh, okay, okay. It's a bit set. I see what you guys are saying. So what we should be doing is we should be, okay. So that's what that is. And then what we could do is to figure out which one of these, we could just AND it with these things. So then I could say bool outline none equals flag and ft outline none. Right? Yep. Let's go ahead and copy the rest of these. Just so I have those for reference real quick. Okay. I want to Control-K /. Come on. Can I not comment that out? Okay, thank you. So we will have outline none, bool outline even odd fill. reverse fill equals flag and bool ft outline ignore dropouts. Wait, ft outline ignore dropouts. Bool outline smart dropouts. This probably isn't the most efficient way to do this too, but this is what I'm doing. Outline include stubs. And finally, that. Oh, and I guess I missed owner too. I swear they were different on the website though. No, even odd fill, reverse fill, or dropouts. High precision and single pass. If set, this flag indicates the outline's field arrays. Points, flags, contours are owned by the outline object and should thus be freed when it is destroyed. Okay, so we don't care about that. By default, outlines are filled using the non-zero winding rule. If set to 1, outline will be filled using the even-odd fill rule. Only works with the smooth rasterizer. By default, outside contours of an outline are oriented in clockwise direction, as defined in the TrueType specification. This flag, if set, is set if the outline uses the opposite direction. Okay, so this is how we can tell which direction this guy is on. Contains overlapping contours. Okay. Oh, cool. So that even like tells us if it's an overlapping contour or something. Huh. But this, I think this is the one that we're mainly concerned with. Do we also have something inside of the contour itself? Okay, so that P point is just a vector, so that's not anything big. So we've got OL contours. C. What does it say? So that's the number of contours. Okay. OL contours. Yeah. So we got contours, which is a short star. So that doesn't tell me much. Flags. Yeah, so these flags, I'm trying to figure out, because I think what we're concerned with this outline even odd fill. I think that's the thing we want. So let's just do outline even odd. Let's do that, and then we'll just say %d, and we'll do that Boolean outline even odd fill. Okay, let's see what happens when we do this, because I'm curious if it's going to be like our on-off points, which is what I'm imagining it's going to be similar to. Do that. No, we just get zeros every time. So that's never set, which is interesting. It seems like it's a talented community Gabe has gathered on Discord. Yeah, we've got a lot of smart people there. Sam, you forgot FT outline owner. Maybe it's in here. Maybe we did miss something. Okay, let's go back up to outline. Number contours, number points, tags. You call it tags. These are the points flags. Oh wait, tags. Okay, this is what we wanted. A pointer to an array of endpoints. If bit 0 is unset, the point is off. Bit 1 is off. Okay, this is what we want. Okay, so we want tag. Thank you. That's what I was looking for. So what does he do here? He says like start end p contour end equals contours pointer to contour end p flag ol tags pointer to flag. Wait, okay, yeah, this says tags. Wait a second. ol tags p flag. Tags, the points, flags, contours, the contour endpoints. And then we have int flags, outline masks. So that's why they didn't call it flags. Okay, that makes sense. But wait, so this is the tags, p flag. So it looks like we should only ever have like bit 0, bit 1, and bit 2 set. And then the flags is what I was looking at. Okay, so bit 0, bit 1, and bit 2. Bits 5 through 7 contain the dropout mode. Okay, so what I want to do is I want to do... We'll say bool, let's see, okay. 0, the point is off the curve. Okay, off curve equals flag and, right? That's bit 0? Yeah, I believe that's how that works. Let me just make absolute sure. What did I have here before? I had all this stuff, yeah. None, so that's 0, 1, 2, 4, 8, 10, 20, 40. Okay, cool. So that's what we want to do. Okay, so bool off curve equals flag and 0. Wait, that makes no sense. Flag and 1, because that's tags. If bit 0 is unset, point off. Okay, yeah. So if that's unset, it's off. If it's, okay, so this is on curve. Bezier control point while it is on if set. I guess we could call that like Bezier control point. So if that's true, that's what that is. Okay, bit 1 is meaningful for off points only. If set, it indicates a third order Bezier arc control point. Okay, so bool third. If set, it indicates a third order Bezier arc control point and a second order control point if unset. Control point equals flag and 0x2. This would be if it's a Bezier control point and that. Right? That's what that means. So it's meaningful for off points only. Which this is off if that's not true. Right? Okay. The point is off the curve if it's unset. Okay, yeah. So that's a control point. Then this is a third order control point if the first bit is off. And then if this is set, it indicates, okay. So yeah, so that's a third order, and then a fourth order, in a second order control point if unset, second order. So that's a second order control point if it's that, and we do not have that. Then we have bit 2. If bit 2 is set, bits 5 through 7 contain the dropout mode as defined by the OpenType specification, scan mode instruction. Okay, so let's just, that would be like bool dropout enabled. We'll just do that, Bezier control point and flag 0x4. Okay, so that's what we'll have it as. Then control point. And then we can have second order, %d, and then we can have third order, %d. So then this would be second order, and this would be third order. Okay. And I guess we'll throw in that last thing too, which was dropout enabled. Dropout. Okay, let's see what this says now. I think this will be much more informative for us. So, Skidome, thank you for following. For some reason, I didn't hear that too. I don't get it. Sometimes I hear it when you guys follow, and sometimes I don't. So, that is weird. Okay, so this is going to be way more helpful. Yes, it is. Sweet. So what we can see here is we get 0, 0, 1, 1, 0. So what this is telling us is this is a line from point 0 to point 1. That's just a straight line. And then what we get here is 0, 1, 1, 0. So that's a cubic curve. And I think we can see that too, because it says it's a second order. Yeah, second order. And then we get 0. So we get like 0, 2 control points, and then we get the end point. And then once again, we get another second order curve, and then we get a straight line. Then we get a second order curve. Then we get another second order curve. That's a straight line, and then we get a straight line, and then we get a regular curve, Bezier curve. Yeah, and we can see that this is a second order. I wonder why we're not getting, oh, no. Okay, so these are not quadratic. So we get, I remember this now. Bits go up in hex very nicely. Yeah, I know. I just realized that too. That's really cool. Second order must be mean quadratic, not cubic. No. So what's actually happening here? So this is a straight line. And then what this is telling us is that there's basically an invisible point between these two. Okay, this is part of the TrueType specs, and it threw me for a loop. So basically what this is saying is we have a straight line here. Then we have and this is to save space. Then we have like what is it? Bezier curve here. But the end point is between this point and this point. So if we take the average of like whatever the between point is between these two, that will give us the third point there, and then we can do the same thing here. I think the third order thing is telling us if it is a cubic spline. So second order is regular, third order is cubic, and that's the reason we see zeros for when we have zeros here, which makes sense. Do we have any third order? We do not have any third order. Okay, cool. So using this, we should be able to construct a data structure that contains all these points. So, man, I was going to stop at 10 today, but this is too interesting for me. Okay, real quickly, I'm going to go take a bio break, and then I will be back. What we're going to do is we're going to create a data structure that looks something like our own glyph outline, right? And this will contain like a vector2 position, and then it'll just be like a Boolean control point, right? And we'll basically have something like this. Yeah, bio break, I know, right? So we'll basically have something like that, and I guess that would be just a vec2. Vec2. Yeah. And I think that should be all we need. And then we will basically fill out a structure, which is like, I guess this is like a glyph. This is like a glyph vertex. And then we'll have like a struct glyph outline, which has like int number vertices. And then we would have like a glyph vertex star vertices. Okay, so that's what we're gonna do. And then we're basically gonna fill in those hidden points, and we'll actually do that. I'll steal that. I stole it from somebody else too. So you'll have to give credit to Nathan, who is the person I stole it from. But yeah, anyways, guys, I will be right back, and then we will continue, fill out this structure, and then we will draw the letter B. I promise you. And this will all happen in 30 minutes because we've gotten the hard stuff out of the way. If it doesn't, then I'll be very sad. But yeah, anyways, I will be right back. All right, I am back. Thanks, Nathan. I'll let him know you thanked him. Okay, so first thing we want to do real quickly is we want to normalize these values, X and Y. They go up very high, and the reason for this is because of our canvas size. So if we can get the canvas size, then we should be able to normalize that stuff, I believe, hopefully. So this is the print outline out G. Do we have, can we go like out G canvas size? No. Can we say ft get canvas? No. Can we get the canvas size from the regular glyph, which is here, or face? Canvas? No. Glyph. Canvas? No. Come on. One of these things has got to have the canvas size. Let's go ft FreeType. FreeType get glyph canvas size. Conventions, canvas. No, why is Google taking me here if it doesn't have canvas size? Okay, pixel size equals point size times resolution over 2. That's not what we want. It's got to be here somewhere. What's my favorite game genre? Me? I guess that's direct at me. Probably, I honestly don't know. So like the games I really like Nintendo games. I love like local multiplayer games. So I guess it's not Nintendo games I love. I love being able to play with a group of friends all in the same room. I hate online multiplayer. I would so much rather have a split screen and like play with a bunch of, you know, the guys, the boys, whatever, and just get to hang out. And so Nintendo party games are great for that since they still build like that. But I also like the original Halo where you can also play over local LAN. That game is awesome. Minecraft, that's also fun. That's one of the exceptions that I'm like, I'm okay with online multiplayer there, but I still think it's more fun if you're all in the same room and you can play local LAN on Minecraft as well. I really like Terraria. That was fun too. I'm thinking of getting back into The Witcher. Half-Life Alex was super fun. I love Valve games like Portal, awesome. Portal 2, also awesome. Wish they had a Portal 3. I played the mod, but I haven't played that other thing. And then I got Beat Saber recently. That's amazing. Really like that. So yeah. Speaking of BioBreak, I frequently watch Humor Bagel in his farting with watch Humor Bagel in his farting with eye contact series. If you haven't seen it, you're missing out. I have not seen it. So Elden Ring has gotten some great reviews. I've wanted to try Elden Ring because I haven't tried a really hard game in a long time. So I usually get annoyed with hard games, but that's another thing. Bennett Foddy. Let's see if I still have that actually, because I got to show you guys, okay? I've got some mad skills when it comes to getting over it with Bennett Foddy. Let's see. I do still have it. Okay. We're taking a detour real quick. Oh no, do I not have it? Wait. Okay, that's a shortcut. Do I have it somewhere in here? Maybe I just extract this. I think it has a password though. It has a password. Crap. We're gonna have to do this another time, guys. I'm stuck on that game. I used to have it. Wait, do I just... There we go. Actually, I do have it. Okay. No, it's empty. Why is it empty? No, come on. Let's see. Do I have it like... Nope, that's not it. Yeah, you can see I have the original Halo in here too. Dang it. Okay. Well, we'll do that next week, okay? Because I haven't played it in a while, but I love it. And me and my brothers got really into it. I think I got my personal best is under 10 minutes, but that's besides the point. Fun game. Okay, anyways, let's go back to this real quickly. Elden Ring, do want to try that at some point, though. I need to get like a PS5 and stuff, too. But how do we get the canvas size? Get canvas size. Float scale. Some other scaling text. That's not what I want. This library is great, but it has so much stuff, and it doesn't have a simple way to get what you want to get. Okay, so we got the ascender, bounding box, char maps, descender, driver, extensions, face flags, glyph, height. Okay, I'm guessing this is the canvas height. Yeah, so let's divide by that when we go into here. We'll say int canvas height, because I actually want to do canvas width and then the canvas height, which makes sense. Why are you popping that up? That's weird. Okay, so then we got that. We will say vec2 position equals vec2 p point x, which is a int. It's an ft pose. What is an ft pose? I think that's just an alias for a float, but let's just double check that. Signed long. So that's just an int. Okay. So we'll do point x over width. P point y over canvas height. Okay. And then we will cast that to float. Cast that to float, which I guess we run the potential of having out of bounds errors there. Okay, let's do that. Let's just normalize this stuff. Position.x, position.y. And let's make sure that looks correct. We will load the glyph. We get the glyph outline. Then we print the outline and we'll say face, width. We have height. Let's see. Face is what I want. Let's just close that one out. Glyph outlines, glyph metrics. Do we have? Okay, so that's the advance. And then we have Y max, we Y min, X max, X min. So I think what we want to do is we want to divide by something, clearly, but I don't know which one. Glyph outlines, glyph metrics. I think before what I've done is I've just shifted left. Here, let's see. FreeType, normalize font position, vertex position. Normalize 2D vertex. That's not what I want. Normalized font size. Do they have anything in here? New face, done face, reference face. Select size, size request. Load glyph. Set char map. I mean, it would be great if we could just get the stuff that I want. Do we, okay, face properties. Is this what we want, maybe? Define a FreeType, set override, face properties. No, I don't think that is what we want. We've got glyph metrics. We have size metrics. Okay, wait, so this might be good. Scaling values used to convert font units to 26.6 fractional pixels. What does that mean, though? A 16.16 fractional scaling value to convert horizontal metrics from font units to 26.6 fractional pixels. Only relevant for scalable font formats. Let's try that. X scale. What was that? That was like metrics or something, right? Metrics? What was that? Yeah, size metrics. Size metrics dot x scale, okay, which is ft fixed. We will see what that is in a minute. Y scale, and what is ft fixed? That is a long. Okay, I think that's what we want. We will see. Why do I want to normalize the points? I want to normalize the points because we are going to scale these. Basically, right, when we position our letters and stuff, we want to scale them according to whatever font size you want. And that's the whole point of this. I'll be able to pass in a scale, and then we'll get infinitely sized scaled fonts for free. But it looks like that didn't work. Oh, well, I'm printing that out wrong. Okay, let's do %2.3f now for these. Yeah. Cool, so that should be good. So just calculate the bounds yourself. Well, you can't just calculate the bounds yourself because there's a lot of weird voodoo that goes on with the fonts, which is why I'd rather use the values that FreeType is giving me because they are more likely to be correct. So this looks almost correct. I'm not. Horizontal pixels per EM, per M. Okay, wait, here we go. The scaling values, if relevant, are determined first during a size changing operation. The remaining fields are then set by driver. For scalable formats, they're usually set to scaled values of corresponding fields in face rec. Some values like ascender or descender are rounded for historical reasons. More precise values for outline fonts can be derived by scaling the corresponding face rec values manually with code similar to the following. So multiply fix ascender by size metrics Y scale. Note that due to glyph hinting in the selected rendering mode, these values are usually not exact. So just calculate the bounds, or there's a function to get bounding box to get. That is probably a good idea. I should probably use the bounding box instead. Yeah, bbox dot xmax. We'll do that. We're gonna have to pass in the xmax and xmin to, yeah, get that correct. So we'll say face size metrics. No, face bbox dot xmin. Face bbox dot xmax, and then we'll do the same thing here. Face bbox dot ymin. Don't know why it doesn't like that. Okay, let's do that. And this will be xmin. Okay, we'll do that, and then p.x plus xmin over xmax minus xmin. That way we're just dealing with positive numbers from 0 to 1. Because otherwise we're going to have weird stuff. Okay, let's see if that looks right. Yeah, and it's happy now. Cool. Okay, so if this is right, then we can move on. Okay, it looks closer. 2, 3. The only problem we're getting is we have 2. We should get values between 0 and 1 only. What is the bounding box? Let's see. I think it's in glyph slot. No, it's in face. Glyph management, maybe it's in here. FT face. Nope. Wait, B box. Data types. No, that's not what I want. Base interface. Okay, here we go. Face. Do they have bbox somewhere in here? Oh, I wish they just had this stuff easier. Their documentation aren't so annoying. FreeType. Bounding box. Face. I remember from the docs that there's cbox or bbox or something. Yeah, we're using bbox right now, but I don't think that's right. Ascent, descent, bounding box. Okay, this is an imaginary box that encloses all glyphs from the font, usually as tightly as possible. It's represented by 4 parameters, xmin, ymin, xmax, ymax, that can be computed. Their values can be in font units if measured in the original outline, or in integer fractional pixel units when measured on scaled outlines. A common shorthand for the bounding box is bbox. Okay. So if that is true, we should never get a value that's outside. Oh, but what if xmin is greater than 0? Okay, that makes sense. So we could have xmin is less than 0, and we could have xmin is greater than 0. So this could be xmax, this could be plus xmin, or this could be minus xmin. So I guess, and we could have the same thing there. Okay, so I guess what we can do is like point x equals xmin greater than 0. If that's true, we'll say float p point x minus xmin over float xmax minus xmin. Otherwise, let's move this to a new line. We want to do plus. And then we'll do the same thing for y. 0. And we'll do basically the same thing, except for y. And that. Then we can just do... Okay. I think that could be a problem, because if the bounding box is greater than 0, then that would have been bad, which we might have had. So we do that. No, I still see 2. Okay, Sam, one is closed packed and one is with padding and stuff. So we have bbox. That's the only box we have, though. We have ascender, we have descender. Do we have to go into glyph bbox? No, we have bitmap, we have like all that stuff. Maybe we do have to go into glyph. Maybe this should just be bitmap, but we haven't rendered it to a bitmap yet. Yeah, let's try that. So bitmap lift, and then we have width. Let's try that. So let's do this. We'll see if this works. If it gets close enough, I think we'll just leave it. Face, glyph, bitmap dot. Actually, we want bitmap left, glyph bitmap dot width plus bitmap left. It was some method, but I don't know. I just saw it in the glimpse when you were scrolling through the docs. Did you? Yeah, it's so weird. I always forget what exactly to do with this stuff because it's just annoying. We'll do this, and then we may have to fix this. Height. No. Dot number rows. Come on, I know it's somewhere in here. So that we've got width, rows, which is ft bitmap. It's an unsigned int bitmap rows. Oh yeah, I think that's it. That's height. Okay, Let's see what happens if we do this. Do that. Okay. No, that's definitely not right. Why do they have to have it so confusing? Get bbox or get cbox in ftglyph? Yeah, let's try that out. Get bbox or get cbox. ft get box. ft get cbox. There we go. Glyph get cbox. Okay, then we have bbox mode, and then we have a cbox. What is that? Returns and outlines control box. The control box encloses all the outlines points, including Bezier control points, though it coincides with the exact bounding box for most glyphs. It can be slightly larger in some situations. Computing the control box is very fast, while getting the bounding box can take much more time as it needs to walk over all the segments and arcs in the outline. To get the latter, you can use the FTBbox component, which is dedicated to the single task. Okay, so we give it the outline, FT outline get cbox. FT outline get cbox. Right? That's what it's called? Yeah. This looks like what we want. For sure. But it doesn't find it. Undefined. Where is this included from? It's right there. Okay. Hash include that with an F. Okay. Yeah, I think this is exactly what we want. Okay. And then I don't even have to pass this stuff through. We can just pass the outline like we were doing before. Thank you guys for getting a much simpler thing. Okay, so get cbox. We want to give it the outline, and we want to give it our bbox. And I guess we could say, what was that? FTBbox. And we'll give it that. We will give it that. Okay, what this doesn't like, FT outline. Oh, I guess we need to give it the actual outline, which is outline. Okay, so that should get us our bounding box. Okay, let's try this again. And do that. And we'll do that. Same thing here. Okay, and same thing here. Okay, let's see what happens with that. Yes, okay. Yes, that looks like it's working. They are all between 0 and 1. Let me zoom that in so you guys can see too. It looks like they are all between 0 and 1. Sweet. Okay. So we've got that now. Now what do we want to do? We want to, let's change the name of this function to create outline. And what this is going to do is it's going to return this guy, which is just going to fill in that guy. And yeah, we'll do this. Okay. Where's that error set? Okay, it's set to 0, and he literally never does anything with it. Why would you do that? You're not doing anything. Okay. Create outline. So this will do that. Glyph res. Okay, so we're going to get this. This is going to contain all of our vertices. So first, we're going to have to iterate twice. The first iteration will be counting the hidden vertices. Then the second iteration will be allocating the memory we need, and then it will fill in that stuff. FT get bbox, nice. Sam. What video was it where you were working on? I'm working on the next video for the Minecraft series. So that one is about player controllers in 3D. And then I ran into an issue, and now we are down this giant rabbit hole, but I like this stuff. I think it's fun. So, okay, so we're going to have to loop through twice. So C equals 0 until C. This is kind of icky. We don't want to. Let's do this. We're going to say that is our first iteration. Okay. Iterate once to count the number of total vertices. Okay, so then we'll say number of vertices equals 0, and we're just gonna unduplicate all the duplication in there. So basically what happens is, let's go ahead and do this one more time. This will be glyph outline. Okay. So if we do that, that's fine. I just want this. Okay, so basically if we have a 0, 0, that's one line, right? 0, if we have 0, 1, and then as many ones afterwards, that's technically, we're using they last. Non-control point followed by whatever's in between these two ones, followed by the 0. If we have a third order, we're just going to like print an error because I'm not supporting third order Bezier right now. So hopefully these will all be second order and we should be good. So basically this is 1, 2, and then we would have a 1, because this is the start of the next one, 2, then there'd be a third one here, then that would be, so that would be 1, 2, 3, 4, and then 5 is hidden, then 6 is hidden, 7, 8, and then we have 9, 10, 11 is in. So that's basically how we're going to have to count this stuff. So say that. We will say this. Why was that throwing an error too? It's so weird. Res.number vertices equals 0. Res.vertices equals null pointer. So we'll do that. Okay. And I guess we don't need that. So we will say somewhere in here, p equals start. Okay, so this is a contour. Each contour, we are going to want to store the contours as separate things too. So we're actually gonna have to change this a little bit more. We'll say struct glyph contour, which will have a vertices and int number of vertices, which is probably the way I should have done this in the beginning. And then this will be glyph contour. Okay, so that's what we're gonna do. Not contour, contour. Okay, so we're gonna do that, and then we're gonna say res.number contours, res.contours, and we can do that right off the bat here. We can say, yeah, because we can get the number of contours here. So we can say number contours equals OL number contours. And then we can say res contours equals G memory allocate size of glyph contour, not contour, times res.number contours. And then we will go and cast that to that. Okay, so we do that. Why is that not happy? Star. Okay, so we do that. We can get rid of this. Okay, then we know which contour we're on with C. C is the contour we're on. Then we know our points. Okay, so for each contour, we'll basically say bool, we are on a hidden point. False, maybe? Actually, let's call this last point was control point. equals false. Okay, so the last point was not a control point when we start. We should start with an off point curve. We can get rid of that now too. So what we can do is, oh, and then what we also want to do is we want to say res.contours c dot number of vertices equals 0, c dot vertices equals null pointer. Okay, so we do that, we initialize that, and then we're going to be incrementing this for as many vertices as we find. And so basically now what we have to do is we have to go like, oh, that's a point, that's a curve, that's a control point. We have to do something like that. So we have to say, let's think about this. So we count the point we're on, right? Then we check the next point. If the next point, so if we are on an off point and the next point is also an off point, this is a line. So then we would do +1, we would do another +1. Then we get to this point. We do a +1 because we're on this point. So now we're up to 3 vertices, which makes sense. Then we would say, okay, next point is a control point. So we do +2. Yes, +2. Then we get to this, we get +1. That takes care of the hidden point. Then we get +2. If the next one is an off point, that takes the hidden point again, and then this point, then we do +1. Yeah, okay, so basically the basic format is we would say for every point, we do res.contours c.number of vertices ++. So we do that. Then we say bool next point is control point equals p flag. Okay, so first we have to see if p is less than or equal to n. So first we have to say p is less than and -1. So that way, or I guess we could just say is less than n since we're going up to less than or equal to n. Just making sure that's not going to break stuff. P point, which we get. Where is P point coming from? P point. Oh, P point ++ here. Yeah, no, I think we want to do -1. Okay, so first we'll check and see if it's -1. If it is not, then that's false because there is no more points. Otherwise, if it is, we're going to say res, or actually we're going to say p flags +1. Right? Yeah, p flags +1. Where's our p flags? Because that's how we're getting this stuff. Yep, flag, which is p flag ++. We want to do star. And we want to AND that with 0x1. Okay, so next point is control point. And I guess that's just p flag. So if this, it's a control point if that's not true. Okay. Whoops. So that should tell us if the next point is a control point. If next point is control point, okay, so that's basically all we want to do. Let's go, and then right here, we'll say printf number control points, or number points. And then we will do res.contours c.number vertices. Let's just make sure it's a reasonable number. So let's try this out now. Also, that ternary can be changed to a ampersand. Don't need -1 really, right? I'll have to check what you're saying in just a second. Real quickly. 105 points, and we've got 40 there. Does that make sense? Let's see. How many points does this? This is 43, 38. Let's count this. Let's just make sure this is right. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I got 26. Oh, you're right. P flag is getting incremented at the start of the loop. Good call. And just check if you don't get the wrong offset. Yeah, that's true. Yeah. So we should do star P flag. And Voxriffs, you said also ternary can be changed to ampersand, ampersand. P is less than n minus 1. This ternary? We want to do like bitwise and there, I think. So you don't need -1 really, right? -1. I think we do need the -1 because he's doing weird stuff with the way he's looping. You know, a normal person would loop normally. We might change this. Yes, that one. I think that needs to be a bitwise and I'm not sure on that yet. Let's see if this is. We're still getting 38, so we got the same number even though I didn't do P flag plus 1. Which is that concerning? No, not that. Oh, okay, you were talking about the -1. Sorry. Yeah, I think we do need that -1 there, but I'm not completely sure. The whole ternary, although it doesn't matter. Oh, I see what you're saying. I could just do that. Yeah, you're right. I'll leave it this way for now just because, yeah. It helps me visualize a little bit better. Okay, so that's P flag and 0x1. And that's not. If the next point is a control point, we want to add 2. Otherwise, see, maybe I miscounted. Let's try this again. Because it gave us the same result, which is interesting. Okay, so we go. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, I just counted that twice, and I'm pretty sure I got 26 last time too, right? I think that's what I got. So this is clearly wrong. So what do? We say 1, next point is not a control point. So I add an extra 1 here, 2. Then 3, next point is a control point, so I add 2. 4, 5, which takes care of both of those. Then that would be 6, 7, 8, 9, 10. Okay, I think we're double counting here. Maybe we do want to look at the previous point. Maybe that's easier. So that would be 1. Last point was that. So that's a 2, 3. So we add 1. And then here. Last point was that. So we add just 1. Then last point was that. They're the same. So we have to add 2. There's 2 hidden ones there. Last point was that. So we just... Yeah, I think we need to look at the previous point. That's probably easier. Which is what I was doing. So I had the right idea first. So, bool. Previous point was false. And this will simplify our logic even more. Because then we can say... previous point equals Bezier control point. Okay, so then what we can say is if the previous point was a control point and this point is a control point. So if we're in a situation like this, there's 2 hidden vertices there. So then we want to add 2. Otherwise, if we have this and the previous point was not a control point, we don't want to add anything extra. There's no hidden points between these two. Wait, is there? No, there is, because that's 1, 2, Then 3 is the start of the next one, which we don't get. Wait, is that? No, we'll add no points there. And then if we have an off followed by an off, we'll add 2 to account for that extra one. So otherwise, if they were not, we will just add 1 there. I think this is what we want. Let's run it. Let's see if we get the correct thing this time. Okay, we're closer. That's 23. Okay. So 0, so that would be 1, and then I go here and I say we add 2, 3, because we're starting a new one and we're ending the first one. So that's an extra 1 added. So 1, 2, 3, we add an extra 1. Then here, if we look back, it's just a 4. Then here, there's 2, 5, 6, then 7, then 8, and then, oh, if we're looking back. Yeah, okay, so this is kind of bad. Oh, okay, if the current point is not, okay, I think I see now. So then we just need one more statement here. If we say else if not previous point was control point, or no, the previous point was a control point and we are not a control point. And then we say res.contours c.number of vertices plus plus. Okay, I think that's the missing case that we had, and this should do it, hopefully. Okay, continue, step over. 28. Okay, let's just see. So this is 0. So this is 1, 2, 3, 4. There's 2 hidden there. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, I keep ending at 26, which makes me think that I'm counting this right. Let's do it one more time. See if I get 26 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay. I've gotten 26 through several countings of that. So there's definitely 26 there. So what am I doing here? So 0. So what am I doing in my brain? I guess if I can do that in the code, we're there. So this is 1. I say 2, 3 because we've just completed a line. So this is end and this is start. So 0 followed by 0 is end, then start. Well, actually, I guess what I'm looking here is just if we're ending and starting. So this end and start is if we're 0 and this previous one was a 0. Ooh, okay. I think I see what's happening. We're double counting this and we're double counting that. Are we? Double counting this. Yeah, maybe the first one is wrong since the initial value. Yeah, you're right. I just realized that too. So bool first. Actually, okay, what we can do is if p is greater than 0. We don't want to count that first one, right? Yes. Or I guess if p is greater than start. Was that double counting all that I was adding? Let's see. So we do that, F10. 27, okay, we're closer. So we figured out one of them. So it was counting that one, which is wrong. Is it double counting here too? So 0, so let's see. So if we're starting then ending, which means that we're on a 0 and the previous one was a 0, or we're on a 0 and the previous one was a 1. So if we're on a 0, we're basically starting then ending, period. So let's just get that out of the way. So if this is not a control point, we add an extra one. That's simple. So that takes care of both of those cases. So it takes care of this case and it takes care of this case. Or I mean, no, it takes care of this case and it takes care of this case. And then the other case we have is, so that's 1, 2, 3, 4. And then we have 2 that we add here. So if we're 1 followed by 1, we're adding 2 hidden ones, which we have right here. Yup. Let's try this again. I removed an if statement and simplified that. So maybe I had some logic flaw in there. Nope, we're still getting 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Oh, wait. Oh, okay. And then we have to exclude the end too. It's counting the end double because it's doing 26, 27. So if P is less than start and P does not equal, yeah, we should start on a 0 and we should end on a 0. So if that doesn't happen, we'll do an assertion failure just to help us out. So if P does not equal end, G logger assert. Okay, otherwise we'll say else G logger assert, not Bezier control point, should start off and end off every contour. Or you could just do minus equals 2 at the end. I could, but this way I can also add that assertion just to make sure that we're not, because there are weird glyphs, and if I use a weird glyph, then I want to make sure I know about that. So I can add support for that. 26, okay. So that makes me happy. I think we are good now. So now we can count them. Then we're going to loop again, and we're going to do the same loop. And we're going to say iterate second time to calculate all the positions. Okay, so at this point, we can say we have the number of contours. That's fine. We've already allocated that. So that's good. Then as we go through each contour, we have the number of vertices. So that's fine. And then what we can do is we can say this is memory allocate size of glyph vertex times contours c dot number of vertices. And then we can do that. Okay, so now we have memory. Okay, then we're going through, we have flag, Bezier control point, third. Yeah, we'll ignore those two. Let's also just throw in no support and no support. Just for now. That way we know if we hit any of those weird cases. Okay, we don't want to add anything. Don't want to add anything. Actually, but this is important. So what is this? This is 2 off points. Hidden, on point, in between. Starting and ending. Push another copy of this vertex. Okay, so we'll do that, and what we'll have is we'll have vec2 previous position, which we'll need, and then we can say previous position equals position. Okay, cool. So if we have 2 off points, there's a hidden on point that is right between this position and the last position. So we can say vec2 hidden point position equals, and then we can say vec2 position dot x minus previous dot x over 2, and we want to do that. and y, x, and no, y and y. Okay, so that's right between those 2 points, which is what we want. And then what do we want to do? We want to push 2 of those onto our vertex stack. So I guess what we need is we want like a vertex stack pointer. I don't know, equals 0, right? And then what we can do is we can push 2. So say res.contours c.vertices vertex stack pointer plus plus equals hidden position. Yeah, we want to push 2 of those. So 2 of those. And I guess what we want is we want dot control point and we want position. So we want to do position. Why isn't it like that? Hidden point position. So that's the positions we also want to set, so we can't really do this. Because we gotta kind of do 2 of those. We need to set a couple things. So we do that, and then this control point tells us whether that's a control point or not, and this is false. And we'll do the same thing here, because that's how this works. False. Okay. Starting and ending, push another copy of this vertex. So then for this, oh, and we also want to remove that. We want to do this, and we just want to give it the same position. And this is not a control point either. Okay, cool. Then what we can do is we can say push. And what we'll do is the same thing here. This will just be position. This is a control point. This is not. And that should be it. Then we should get everything. We should have a proper structure at the end of this with the control points. Let's just double check. We will go and see what we get printed out, and then we'll just make sure that's all correct. Okay, cool. So we get res. Delete. So let's do res. We have contours. We have 3 contours. That's right. So let's do res.contours2.vertices, and let's show the first 10 vertices. Okay. So we got that here. Now, if we look here, what we should get is we should get 346,517, 346,517, and then we get a bunch of extra stuff that is just not included up here, which is fine. Okay, then the first one, so then we should just get 346,216 twice. So we get 346,216, we get that twice. And then we get a control point, which should be 346,162, which 346,162, that's correct. Oh, crap, I wish I could highlight both these at the same time. And then we should get a hidden point, which is between this point and the next point. 346,162. So this should be a hidden point, then the next point, which is 008,003. Is that right? No, it should be 383,071. Okay, so we get that, hidden point, that. Okay, we're getting it there. So we've got like 3 hidden points for some reason. Oh, well, we push, wait. 346,161. Okay, that's that. 346,162. Then we should get 2 hidden points. Then we should get this point. So that should be hidden, control. Why do we get this? 36309. What is that? That's this control point. Oh, ooh. That's because we're getting, okay, so we're doing it reverse there, which isn't what we want. So what we want to do is we want to say if it's Bezier control point and not last point, previous. Otherwise, we want to do the hidden point, and then we want to do that point. Okay. So this is why we check things. So let's do this again. And we should be good. No. We have written over bad memory. Is this right? If, oh, else if, not Bezier control point. Yeah, that's what we want. Okay, so we go there. There we go. That's good. So let's expand this again. We should get 346162, which is this guy, which we get 346162 right there. Then we should get off point, on point, which is 36309. 36309. Cool. So that's true. And then these two off points should be, oh, we can see this too. False, 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 true, false, false, on point, true, control point, which is good. So we see true, false, false, true. And we're getting a negative there. How do we get a negative? So 09. I think we want to take the absolute value when we're subtracting. Oh, wait, no, I should be adding this to the first point, shouldn't I? So this is the offset to add. I know, we are getting closer and closer. We're very close. Okay, so last thing is when we do this. Yeah, so this is the delta. And then we're dividing by 2. But then we need to add that delta to our previous position to get the actual position. So then we need to do one last step, which is plus that. Okay, so that should be good. Let's check one more time, and those should no longer be negative, but they should be in between those 2 points. So if we go that, okay, so we get false, false, true, false, false, true. So these are the in between, 354, 354, 363. Sweet, so that is in between. And then if we look at that, 161, that is 09, and that's 128, 128. That's in between. We're going down. Cool. Okay, guys, so we've got this res. Let's go ahead and let's go. Where are we getting that? We're getting that inside of our application, right? Yeah. So we get that here. Let's do, we need to have these be public. This stuff. Okay, so let's make these public. Fonts.h. That. Okay. So we got that public. We can eventually make it internal and do all this stuff inside, which we will eventually do. But for now, let's just render the first contour. Okay, so glyph equals that. What did I call it? Glyph outline. Okay, so we got the glyph outline here. Glyph outline, right? What is this saying? Void to, oh, and then we also need to change that. Right, okay, so then we'll do that. Okay, and we will return that. Okay, cool. So now we got that. We've got that in here. Now what we want to do is, while we're running, let's just go ahead and we will render it right here. So we'll say for int vi, so vertex index equals 0 until vertex index is less than glyph outline dot contours. We know that there's going to be 3 contours because we're doing this all manually. Vi plus plus. So this is going to get us every single vertex. And then what do we want to do? We want to go plus equals 2. So we want to go up by 2, right? So we're going to have either a line or we're going to have a Bezier curve. If we have a line, we just want to draw a line. So bool is line equals vi equals glyph outline dot contours to dot vertices vi plus 1 equal or dot control point. So if this is not a control point, we have a line. Otherwise, we have a Bezier curve. Since we have the Bezier curve, let's just render the Bezier curves for now, since those are easier, sort of. It doesn't matter. Let's say render draw line. We do have both. Let's do both. So start would be our glyph outline dot contours 0 dot position, or I guess dot vertices vi dot position. So that's v0 vi plus 1 v is that style styles default style. Okay, so that's what we'll do for that. And then for this we need to get p0 p1. So let's just do this. We'll say const vec2 ref p0 equals glyph outline dot contours 2 dot vertices vi plus 0 dot position. So we got that. P1, P2, 1, 2. And then what we're also going to do is we're going to say vi plus plus at the end of this, just so that we increment 3 since we've just consumed a glyph outline. And then what we can do is we can say const, we'll say vec2 uv0 equals, and we basically want to normalize these guys. Going for personal best today or what? I guess so. I don't know. We will see what happens. Okay, so uv0 is p2. We want to normalize these values. So bounds equals p2 minus p0, right? That's going to be our, and I don't have, these are custom structs, so I don't have like operators and stuff. X minus p0 dot y. Okay. Okay, so we got that. So that's our bounds. And should those always be positive? No, there's no guarantee those are positive. So we will also say, I know I have GLM and I'm not using GLM, but that's for different reasons. Okay, so then we'll say the absolute value of those. Then, okay, then we can say vec2 uv0 equals p0.x over bounds.x, p0.y over bounds.y. And we should be able to do that. 1, 2. 1, 2. 1, 2. 2, 1. That was wrong. No GLM. I do have GLM, but there's, yeah, other reasons. I've been doing everything except paying attention to the stream today, but just thought, is he still going? Yes, and we are just about to reap the benefits of everything we've been doing. Draw Bezier. Okay, so then we will go P0, P1, P2, UV0, UV1, UV2, styles, default style. Okay. Fingers crossed. I have no faith in this, but we will see what happens. Must return a value. Oh yeah, if we fail, we'll return nothing. Okay. Lots of failure points, which isn't very great, but I guess that is great because then you can handle all those errors. Hopefully reap the benefits. Oh, what is this? Okay, you guys, That may not look like much, but let me tell you. This is the inside of the second loop of B. Can you see it? Like, so we're getting red here, but the only reason we're getting red here is because we have our contour flipped. So this is going convex when it should be concave. So we basically just need to figure out like which side it should be, and we can figure that out. But if we go ahead, and yes, we're gonna have memory leaks. If we go ahead and just do this for every single one, we should sort of see the rough outline of our letter B. So if we go here, and if we go for C until C is less than glyph outline dot number contours. Okay, and then we do that. And we change this to C. We change, oh, and I was using 0 here. So that's why that was wrong. Okay, so that's good to know. That's why that line was misplaced. And then we do C there, and yeah, let's see what happens. Thank you, Voxel Riffs. You are hyped for us all. Thank you. Okay, look at this. So we've got the back curve, right? Then we've got the inner. So if we look at what we're trying to draw here, we are trying to draw, I think I'm using the Baskerville font. So if we move this out of the way. So if we go Windows, Fonts, and we look at Baskerville, which is this one. Okay. So look at the capital B, which we have right there. Can we cannot zoom it in or anything. If you look at the capital B though, it has kind of those little edges on the back, and that's why we see this curve. And then what would happen is we have the exterior, and then we have those parts. Maybe discard instead of putting white. Well, we do want to put it white. We just have to figure out like the winding order of these ones, and then we just need to fix the winding order, and then that should be correct. That's the only thing that's going on there. Oh man, finally. What color is that black background? I like that color. It's like hashtag 2E2 something something. It's let's see. It's from some code colors that I use. If we go here, I have it somewhere. Yeah. It is at the top of this file. This color. If you want to use it. Okay, so I am pretty happy with this. Yeah. It looks like we're missing those horizontal lines and these. Wait, no. Are we missing it? No. Okay. So what's happening here is we have 3. I wish I could like zoom this in. Let's do this. We're going to open up Inkscape real quick, so we can examine in detail and just ensure that this is all correct, which it looks like it is. So if we do text, do capital B, and we go Baskerville face. Okay. So what is happening here? Can I not zoom in? I guess I can't. Weird. Okay. Whoa, Inkscape is just like broken. It's not working. What we have here is this is contour 0. Should be this outer contour, right? So this is contour 0. Right? And then this would be contour 1. And then this would be contour 2. Do we have that? We've got this back edge. I don't see it going horizontal though. Unless this is the back edge, and then we're just missing this horizontal line for whatever reason, and then this is that, and then we have inner contours here. It looks mostly right. There's just like some inconsistencies that are kind of concerning. But hey, let's see. Okay, so if we do A, capital A, does that work? Because no. Why did this happen? We were close. We were very close. vi plus 1. We didn't get any. So does this mean that it ends on a non-control point? Wait, what's happening here? So is line I plus 1. Oh, we should be checking -1. Maybe that's why the B was messed up too. No. What is VI? 117,000. Okay, so. Okay, that's completely wrong. Oh. Duh. C. Okay, maybe that's why the B looked wrong. Let's fix this again. I think that's probably what we had wrong. We were doing something weird. There we go. Okay, that's even better. Okay, there we go. So now we can clearly see the first contour, which we go around, and then we see the second contour, and then we see the third contour. Okay, this makes me more confident. We are doing something right. Let me just double check this loop because now I'm concerned. I think we do want that to be like that. And now we should get that because we're not seeing this. No, are we? Wait, no, I am just barely seeing some red down there. I think this is like slightly curved. Yeah, I think this bottom portion is slightly curved and that's why it's just barely visible there. But yeah, this is good. Okay, so then if we were to do A, we should see an A. If I were to do like a Chinese character or something, like Mandarin, I guess, Mandarin character or something, this will not work right because those are multiple glyphs composited over each other. So that's a little bit trickier. Sweet. Okay, so we can see there's some... The reason the lines are so thick is because of the way that I have my line rendering. I'll have to fix it so that it can use these proper widths and stuff. But you can see that there's like some very faint outlines there of the Bezier curves. This is great. I am very happy with this. What's a complicated character? Lowercase g. It's my name and it is a complicated character, isn't it? It is, because it just broke our thing. Should start off and on, end off every contour. Oh, okay. We were missing one. This is good. This is good. Okay, wait a second. Guys, we're missing one key feature. The B. I noticed this too, and I just assumed that I was, I literally just said this. Good thing you didn't do minus equals 2. That's true. Okay. Where's this bottom line? I said it's just probably a Bezier curve. It's not. There's also the implicit assumption. He might have to take a chill pill after the end of the stream. No, I like the hype. Thank you. Okay, so what's happening here is this connects to this. So a contour ends and starts. So what we have to do is at the end. So basically, if this was a 1, then it would be 0. It would be like, basically we do the same thing and then we end there. So what we should be doing is, we can fix this really easily. Right? Because what we can do is just change this to less than or equal to. Oh, which they're doing. So they already thought of this, and I just assumed that this was a problem. So we actually do want to count the end. And then what we want to do is... we just want to do C mod. Wait, no, we want to do vertex stack pointer mod. Let's see, what is this? Okay, that's fine. Oh, and we also need to fix this in our first loop too. This is dangerous because that could very easily go wrong. Okay, so we just want to go all the way up to end. That's all good. And then position P point. Do they already have this taken into account too? P points. No, they do not. Okay, so P point should be like the very last iteration. We should go back and wrap to the beginning. What is P point? That is a star, right? Vector star, yeah. So what we want to do here is we basically want to say P point plus 1. And then we want to do mod P point minus start. And we're going to get, because this is pointer arithmetic now, so it's not going to be very happy with this. Yeah. Since this is a star. So I'm going to do something stupid. We're going to say a pointer is just a 64-bit number, right? So we're going to do this. And then we're going to do this. Yeah, and that should be the same. I mean, it's not actually good. Let's see what happens real quick. Okay, so we got P point X. Read access violation. Oh, we also have to fix P flag, don't we? Wait a second. Do we have to do this? No. We'll leave that. Oh, wait a second. Okay, so this is a little bit more complicated than I thought. It should be pretty easy, but since we're using pointer stuff here, it's a little bit weird. Okay, so we could fix this. I'm gonna put a to do for now, and then we'll leave this until like next week when we go back and start working on this again, because I really need to start running some errands today, unfortunately. But guys, this has been great. Let's just make sure I didn't break stuff so I can push this, and then we'll keep working on it hopefully next time. This has been great. We know exactly what's wrong here. We just need to loop around. It should be a simple modulus, but I need to switch up those loops so that they're not using pointers and all that garbage. So that we're actually doing stuff a little bit simpler. But thank you for watching. I hope you guys enjoyed it. We did make a lot of progress, even though this may look very ugly. This is great progress, and we're super close to being able to render infinitely scalable vector fonts relatively cheaply. The only big thing is like the RAM, video RAM is going up here, but we'll fix that eventually. But yeah, thank you for watching, guys, and I will see you all next week. Thanks. See ya.